Hello and welcome to Sleepy Science. I'm really glad you're here, whether you're winding down from a long day or simply curious about the strange tricks your mind can play on itself. Tonight, we'll float through some of the most baffling illusions your brain creates. From frozen moments of time and invisible blind spots to phantom limbs, echoing memories, and the subtle ways your senses deceive you without you ever noticing. These aren't magic tricks. They're windows into how perception really works, and why your version of reality may be more fragile than you think. If soft science helps calm your thoughts or opens new doors in your mind, feel free to like the video and subscribe. It helps other curious minds find their way here too. Now, take a slow breath, settle in, and let's begin our quiet descent into the delicate strangeness of perception. Chronostasis. You glance at the ticking clock, and for a fleeting instant, the second hand seems to stop. Not slow down, not hesitate, but stop, frozen mid-air, defying the very idea of time moving forward. Then, as if catching up with itself, it jumps suddenly, and the rhythm of seconds resumes as though nothing strange ever happened. Maybe you blink, maybe you question yourself. Was that real? Did time just pause? You've likely felt this before during a late night glance at your phone, or when looking quickly at a watch after being distracted. It's subtle, easy to miss, and yet unforgettable once noticed. That eerie sensation, when reality seems to stutter for a beat, is called chronostasis, and it might be one of the most peculiar tricks your brain ever plays on you. At first, it feels like a glitch, as though the world momentarily stepped off script. But unlike technological malfunctions or dreamlike déjà vu, this isn't a flaw in your perception. It's part of how perception works. You're not broken, you're not hallucinating. You're simply being human, caught in the delicate seam where sight and time meet. Chronostasis is a scientifically documented illusion, a brief temporal distortion that occurs when you move your eyes from one focal point to another. And to understand why this happens, you have to understand a little more about how you see the world. Or more precisely, how your brain constructs the illusion that you're always seeing it continuously. You think you see everything as it happens, a seamless feed of reality pouring through your eyes like water through an open pipe. But in truth, your vision is built from broken frames. Every time you move your eyes, even slightly, your brain goes blind for a split second. Not metaphorically, literally during a rapid eye movement or saccade. The brain suppresses visual processing to avoid blur. You shift your gaze, and in that moment, you're not seeing anything. Your eyes are in motion, but your experience of vision pauses. And yet, you never experience that blankness. Because your brain does something astonishing. It fills in the gap. Instead of showing you what's happening in real time, your brain delays the visual moment, just long enough to stitch the past and present together. It grabs what it thinks should be there, based on memory, expectation, and habit, and renders it as seamless. It's like watching a movie where a few frames were missing during the cut, but your mind painted them in anyway. You're not just observing the world, you're editing it as you go. Chronostasis is a side effect of that editing. When your eyes land on a new object, say, the second hand of a clock, your brain fills in the blank space of that saccade with a projection of what it believes you should be seeing. But here's the twist. Instead of assuming movement, it often assumes stillness. So the clock's second hand seems to freeze. Not because it actually did, but because your brain inserted a still image for a brief window, believing it was helping you maintain continuity. Time didn't stop. Your perception of time did. It's easy to think of this as a mistake, like a lag or a bug in consciousness. But it's not an error. It's an evolutionary feature, a clever trick to stabilize your world when your eyes are darting across it. Imagine if you saw every blur, every flicker, every real-time displacement your eyes experience. You'd be dizzy, disoriented, unable to navigate. Instead, the brain builds a world that feels solid and smooth, a world that only seems like it's always been there. A world stitched together with illusions of constancy. Chronostasis is not a fault in your system. It's part of what makes the system function. But now think about this. If your perception of time can be rewritten, if your brain can fill in moments with its own best guesses, how much of your experience is real? How much is projection? How much of your daily life is based, not on what's truly there, but on what your mind thinks should be there? You blink, you shift focus. You reach for your phone, glance at the time, or turn your head during a conversation. And in those transitions, in those seemingly insignificant slips of attention, your brain takes liberties with reality. It rewrites time to keep your world steady. But in doing so, it quietly reminds you that what you experience isn't always what exists. This doesn't just apply to clocks, it applies to everything. The faces you see, the voices you hear, the memories you recall. Even your sense of self. If your brain can invent stillness to cover up a gap in vision, it can do the same for thought, feeling, belief. It doesn't lie maliciously, it lies lovingly, trying to protect you from chaos, trying to make the world make sense. There's a strange comfort in that, and also a subtle sadness, because it means you never truly see the world as it is. You see it as it is assembled, filtered through the lenses of evolution, memory, and meaning. You don't live in real time. You live in edited time, and every moment you believe is now is already slightly past. Even this one, chronostasis, is like a soft whisper from the unconscious mind. You don't see time, you feel its echoes. You navigate a symphony of guesses and reconstructions. You don't experience the second hand's full movement, only the parts your brain chooses to let through. Reality doesn't arrive all at once. It's drip, fed to you, one constructed instant at a time. And perhaps that's why you sometimes feel like time is slipping, like days vanish, like memories blur, like life passes faster the older you get. It's not just aging, it's the accumulation of edited moments, the illusion that continuity equals meaning. But life isn't made of smooth transitions. It's built on leaps, on saccades of the soul. Jumps of awareness between what was and what is. You stitch it together without noticing, you carry on, trusting that what you feel is real enough to follow. Yet now you know, some of those real moments weren't captured, they were painted in. Time didn't stop, but you were given the gift, or the illusion, that it might have, even if only for a breath. So the next time you look away, and glance back, and feel time hold its breath, remember this: that frozen second is yours, not because it happened, but because your mind wanted it to. Sleep well inside that stillness. It was never truly silent, but it felt that way, and sometimes that's enough. The hollow mask illusion. You look at a face, and you trust it. Maybe not the person behind it, but the face itself, the structure, the forwardness of it, the clarity of eyes, nose and lips all pointing toward you. You don't question its direction, its angle, or its intent. Your brain interprets faces so automatically, so instinctively, that even the suggestion of a few shadows arranged the right way, is enough to light up entire neural systems built for social connection. And yet, under certain conditions, your brain betrays you. You stare into a hollow mask, the concave reverse of a human face, and what you see is not what's there. The inside curves outward. The sunken nose appears to protrude, the cheeks rise. The smile seems to follow you. The face rotates backward, and yet it looks like it's spinning forward. You're watching the impossible. An illusion so powerful, your brain rewrites reality in real time. This is the hollow mask illusion, a profound testament to how deeply your perception relies not on truth, but on assumption. You don't just see the world, you predict it. You fill in gaps, you correct errors, you smooth over inconsistencies to preserve meaning. The illusion doesn't merely trick your vision, it exposes the machinery behind it, and what it reveals is both elegant and unsettling, that your understanding of what is real is shaped less by what enters your eyes, and more by what your mind expects to find. In your everyday life, You rarely notice the assumptions your brain makes. You navigate streets, hold conversations, glance at expressions, and react accordingly. You trust your senses to report what is there. But vision is not passive. It is not a mirror reflecting reality back to you. It is a dynamic, inferential process. And nowhere is this more evident than in how you perceive faces. The human brain is wired for face detection. Evolution has made you exquisitely sensitive to facial features. Specialized regions, like the fusiform face area, light up even when you view vague approximations, cartoon characters, emoticons, even power outlets, or clouds shaped like eyes and a mouth. This readiness to see faces means your brain often prefers to see a normal, convex face, even when that's not what's present. When confronted with a hollow mask, your visual system, honed through a lifetime of forward-facing faces, refuses to believe what the eyes are reporting. It overrides the raw data with a more likely interpretation. That must be a face protruding outward, not inverted inward. And so, the concavity of the mask flips. You perceive what evolution has conditioned you to expect, not what physics is presenting. Even when you know it's a hollow mask, even when you place your hand inside it, feel the curves dipping inward. Tell yourself it's not real. Your perception remains stubborn. You can't unsee it. Knowledge doesn't overwrite sensation. But there's something more happening here. The illusion doesn't just flip the geometry, it follows you. As you move around the mask, the inverted face seems to rotate to keep its gaze on you. It tracks you like a living presence. And this part of the illusion taps into something even deeper than spatial assumption. It touches your sense of agency, of being observed, of reciprocal awareness. Your brain interprets that persistent gaze as intentional. You feel seen, even though you know you are not. This effect arises because your depth perception mechanisms, such as stereopsis and motion parallax, are being overridden. In the hollow mask, all visual cues point to it rotating toward you, but your brain insists it is rotating away. The result is a haunting inversion of motion and presence. A face turned inside out, watching you back. A hallucinated awareness, constructed entirely within your perception system. And it's not just a curious trick. It's a mirror into the architecture of your consciousness. There's a philosophical weight to this. If your mind insists on projecting faces outward, even when they're inverted, what else might it be projecting outward that isn't truly there? What other parts of your world are filled in, completed, guessed? How many of the people you encounter each day are, in some unconscious way, being seen not as they are, but as your brain needs them to be? The hollow mask illusion is not about a plastic object or clever lighting. It's about you. Your brain cannot stand a void. When confronted with missing or inverted information, it imposes structure. Not because it seeks truth, but because it craves stability. You are constantly living inside an interface that balances accuracy with efficiency. And sometimes, that balance leans toward comforting fiction. Consider how faces represent more than just geometry to you. A face is connection. A face is trust, danger, curiosity, attraction, disappointment, memory. You've spent your entire life learning to read faces, to extract emotion, intention, context. The human face is your portal into another's mind. So when that face is bent in ways that break your visual logic, your brain recoils. Not just visually, but emotionally. There is something uncanny about a face that behaves in a way it shouldn't. A face that floats. A face that inverts. A face that tracks your movement without moving itself. And yet your mind makes it real, insists that it is forward-facing, expressive, responsive, because it cannot tolerate the alternative, that what appears alive is hollow, that what watches you is empty, that what resembles you is not of you. In this way, the hollow mask becomes more than an illusion. It becomes a metaphor, a reflection of your tendency to fill voids with meaning, of your refusal to accept hollowness, either in objects or in people. It becomes a quiet parable for your emotional life. How often do you mistake familiarity for connection? How often do you assume depth where there is only surface? How often do you trust a smile because it's easier than seeing the emptiness behind it? You are a meaning-seeking creature. You see faces in the moon, intentions in randomness, patterns in noise. You believe not only with your mind, but with your eyes. And when those eyes are tricked, it reveals just how fragile belief really is. There's a psychological condition known as schizophrenia, in which the hollow mask illusion does not occur. People with this condition often see the mask correctly, as concave. Their brains, for reasons still being explored, do not override the raw sensory input with top-down assumptions. This discovery has led researchers to consider whether the illusion could one day help diagnose or understand deeper aspects of cognitive architecture. What does it mean to see accurately, but feel detached from reality? And what does it say about you, that you see the illusion, but don't see what's truly there? In a strange way, the hollow mask illusion is both a symptom of healthy cognition and a doorway into altered perception. It shows you the boundary between sensation and interpretation, and how thin that boundary really is. And perhaps that's what makes it so haunting. You're not just seeing something impossible, you're seeing how your own mind resists impossibility. You're witnessing the defense mechanism that protects your worldview from collapsing under ambiguity. You are wired to prefer a plausible lie over an unsettling truth. And the hollow mask is that lie, rendered in plastic and shadow. When you look into it, you are not merely observing an optical trick. You are confronting the scaffolding that holds your mental reality together. You are staring into a face that isn't a face, and watching your mind force it to become one. You are watching the dance of neurons, the algorithms of survival, the quiet genius of self-deception. And for a moment, just a moment, you realize that seeing isn't believing. Believing is what makes seeing possible. So you turn your head. You look again. The face follows. The nose juts out. The cheeks round. The illusion persists. But now you know. You know it's hollow. You know the truth is deeper, more inverted than it appears. And still, your mind prefers the comforting forwardness of a face that meets your gaze. A mask that isn't really watching you, but feels like it is. A world that isn't quite real, but feels like it must be. And maybe that's enough. Maybe that's the only way your brain can carry you forward. By rounding the edges, filling the holes, and stitching together a reality that's not entirely true, but just believable enough to keep you sane. And in the quiet of that illusion, as the mask turns, and you stare back at yourself, you feel something strange, a softness, a sadness, maybe even a kind of peace, because deep down, you've always known that not everything you see is real. You've always felt that some part of your world is hollow, and still, you walk through it. Still, you believe still. You smile back at the masks, the McGurk Effect. You hear a sound clear and crisp, a simple syllable like ba or ga, and you think it ends there, that what enters your ears is all there is to know, that hearing is a direct line to truth. But then you open your eyes and the truth begins to bend. A face is speaking to you, lips moving in a pattern that doesn't match the sound. And suddenly your brain does something strange. It changes what you hear. The sound hasn't changed. The audio is the same, but your perception warps, collapses inward, and reconstructs something new, something that never existed. You hear a third syllable entirely, like da or tha, a phantom between the voice and the lips. This is the McGurk Effect, and it doesn't just blur the senses, it reveals how deeply your reality is built on compromise. You think of sight and sound as separate systems, parallel, but independent. Yet in truth, they are fused at every level of your experience. What you hear is shaped by what you see. What you see colors what you hear. And this quiet illusion, this unexpected auditory rewrite, is not an error or a bug. It is how your brain survives a noisy, ambiguous world. The McGurk Effect is a window into multisensory integration. the process by which your mind combines different kinds of sensory information into a coherent picture of reality. It's not just that your brain can blend signals from different sources, it must. Without this blending, your perception would fracture. You would be overwhelmed by competing signals, locked in a storm of conflicting stimuli. Instead, your brain negotiates. It seeks harmony. When your eyes and ears disagree, it invents a middle ground, not what's seen, not what's heard, but what makes the most sense together. The McGurk effect demonstrates that your perception is not passive, it is generative. It's not receiving the world, it's constructing it. When you first encounter the effect, it's unsettling. You play the clip again, ba, ba, ba. But when the lips mouth ga, you hear da, over and over. Then you close your eyes, and it's ba again. Open them, da, close them, ba this back. And fourth is more than a party trick. It shows you that what you hear isn't just sound, it's interpretation. Your brain doesn't rely solely on your ears to process speech. It uses your eyes too, tracking mouth movements, lip shapes, jaw tension, and synchrony with auditory cues. This visual data helps you resolve ambiguity in noisy environments. In fact, in loud rooms or over poor audio, your brain relies even more heavily on visual input to decode what's being said. But this system has its trade-offs when the signals don't match. When you see one thing and hear another, your brain doesn't freeze. It fuses. It tries to resolve the conflict by creating a hybrid that didn't actually occur. And that hybrid is what you consciously perceive. This is called perceptual binding. And it's not just a neat quirk of language, it's essential to your experience of being in the world. You are constantly merging signals, sight and sound, touch and pressure, rhythm and timing. The McGurk effect is just one of the rare moments where the fusion fails to stay invisible. It surfaces, it reveals itself, and when it does, it pulls back the curtain on how much of your reality is invented for the sake of simplicity. This illusion doesn't require language or complex syllables. Even infants just a few months old show susceptibility to it. It's not a learned behavior, it's a built-in feature of how your brain constructs coherence. Neuroimaging studies have shown that areas in the brain like the superior temporal sulcus, which process both auditory and visual stimuli, light up differently depending on whether the senses agree or conflict. That is, your brain has regions specialized not just for sound or sight, but for the relationship between them. And when those regions detect a mismatch, when the mouth says ga, but the sound says ba, they synthesize something in between. That da isn't real. But it's also not wrong. It's your brain's best guess at what's most probable in a conflicting world. It's your mind doing what it always does, choosing plausibility over precision. This goes beyond perception. It touches memory, identity, belief. Your mind always prefers a story that fits, even if it isn't true to a truth that feels broken. The McGurk effect is not a malfunction. It's a demonstration of how belief is layered into your very senses. And yet, what does that say about your experience of truth? If you can't trust your own ears, if your eyes can reach in and change what you hear, what else is susceptible? How much of your world is a consensus between different parts of you, rather than a reflection of what's actually out there? You think of your senses as gateways, conduits to reality, but they are more like diplomats, negotiating perception on your behalf. They interpret, soften, blend, approximate. They resolve contradictions, not by pointing them out, but by hiding them. You live inside a stitched-together tapestry of sensory agreements. The McGurk effect is one of the rare tears in the fabric, a place where the seams show, a place where your constructed perception flickers, and you glimpse the machinery behind the curtain. This effect isn't limited to laboratory clips or staged videos. It's happening every day subtly, as you watch someone speak on television, or during a video call with lag, or in a conversation at a noisy cafe. Your brain is constantly making compromises between sensory inputs. weighing visual confidence against auditory clarity. In some cases, like in noisy environments, you might hear a word before it's said, because your brain predicts based on lip movement. In others, your ears and eyes argue briefly, and your conscious mind is simply handed a verdict. Not the raw data, but the resolution, and like a good judge, you accept the decision, unaware of the debate that took place beneath awareness. The McGurk Effect is a whisper from that subconscious courtroom, a reminder that your mind is constantly choosing your experience for you. There's a metaphor here, of course, one you can't ignore, that what you perceive to be real isn't always the raw truth, but rather the version that your mind can live with, that your eyes and ears, like old friends with different memories, often have to compromise. And in that compromise, something new emerges, not always correct, but coherent. Think about the people you know, the memories you cherish, the beliefs you hold dear. How many of them are sounds perceived as interpretations shaped by conflicting signals that your brain resolved into something that felt true? The McGurk Effect reminds you that coherence is a choice, not of the world, but of your mind. You crave resolution, you seek alignment, and when alignment fails, you invent it. Even now, as you sit here quietly, your senses are working together, not as separate channels, but as an orchestra. When the violin is slightly off, the cello compensates. When the piano slips, the melody shifts. You never hear the dissonance, you only hear the harmony, and maybe that's beautiful. Maybe that's how you survive a world that rarely makes perfect sense. But it also means that what you believe is seamless may be stitched. What you feel is natural may be negotiated. And what you hear, that simple sound, may be something entirely new, born not from your ears, but from the tug of war between two truths. So the next time you listen to someone speak, and something feels off, not quite wrong, but different, remember that your mind may be choosing between signals, that what reaches your awareness is not always the world as it is, but the world as it feels when senses shake hands. The McGurk Effect is not a failure. It's a glimpse of how deeply your reality is woven from cooperation. It's the sound of vision whispering into your ears. And if that sounds strange, that's because it is. But strangeness too is a form of beauty. And maybe your world was never meant to be raw or flawless. Maybe it was always meant to be stitched together like a conversation between senses. Imperfect, negotiated, and uniquely yours. Rubber hand illusion. You sit at a table, your real hand hidden behind a barrier, a rubber hand placed before you, lifeless, expressionless, neutral in every way, just silicone and paint and approximation. And still, something begins to happen, something strange and quiet and gradual, something that makes no rational sense but feels uncannily real, as someone strokes both your real, unseen hand and the fake, visible one in perfect synchrony. You begin to feel the touch on the rubber hand, not on your own skin, not on your body, but on that inert object across from you. Your mind, confused by the aligned signals of vision and sensation, rewrites the boundaries of yourself, and you begin, irrationally, inevitably, to accept the rubber hand as your own. This is the rubber hand illusion, a deeply researched phenomenon that reveals how fragile your sense of body ownership truly is. How the you believe in, the one you point to, protect, decorate, and identify with, is not a fixed biological fact, but a construct maintained by your brain, moment by moment, through the integration of sight, touch, and proprioception. Your body image, as solid and personal as it seems, is not stored like a map in your mind, but is actively generated through feedback loops, recalibrated in real time, subject to revision and error. And when the visual input of a hand being touched matches the tactile input of your own hand being stroked, even if the visual hand isn't yours, your brain fuses those cues and accepts the fake as part of the self. You don't just feel the illusion, you become it. And that feeling of ownership is not a metaphor, it's measurable, reproducible, and disturbingly powerful. Some participants will flinch, when the rubber hand is threatened, react physiologically. Increased skin conductance, pupil dilation, as if their own flesh were in danger. In that moment, they are not pretending, they are embodying. Their brain, quite literally, has moved the boundaries of self from muscle and bone to foam and pigment. But why does this happen? How can your brain, evolved over millions of years to protect your body, maintain your identity, distinguish self from other, be so easily tricked? The answer lies in the way your nervous system builds a coherent picture of where your body is in space. You are born with certain proprioceptive abilities, your body's ability to sense its own position, but that map isn't fixed. It updates based on use, context, and sensory feedback. Your brain is always trying to reconcile competing information, what you see, what you feel, and what your internal senses tell you. In most situations, these inputs align. But in the rubber hand setup, they diverge in a very specific, very deliberate way. Visual dominance is allowed to override proprioception. Your brain has to choose, and given that it sees a hand being stroked where the sensation of stroking is also being felt, it concludes that the visible hand must be yours. The real hand, unseen and increasingly discounted, fades from the narrative. What this teaches you, what it forces you to confront, is that even your body is a kind of assumption, that the borders of yourself are negotiable, that your brain prioritizes coherence over accuracy. The illusion isn't about deception, it is about construction. You are not perceiving the world and your body separately. You are blending them into a continuous stream of self-experience that can be edited without your permission. And this editability extends far beyond the laboratory. Consider how easily your mind adjusts to wearing gloves, or operating tools, or even controlling avatars in digital space. The line between where you end and the external begins is not as firm as it feels. The rubber hand illusion has been extended into full body illusions, using virtual reality, where participants begin to identify with entirely artificial bodies. And this raises deeper, more unsettling questions. If your brain can be convinced that a fake hand is yours, if embodiment can be transferred so easily, what does that say about the nature of identity itself? What does it mean to say this is me, when me can migrate with a few coordinated stimuli? You are used to thinking of the body as the anchor of the self, the constant in a world of shifting roles, thoughts, and emotions. But the rubber hand illusion gently undoes that assumption. It shows you that even the feeling of having a body is a story your mind tells. A story that can be revised with startling ease. You are not your body. You are the brain's current belief about your body. And in that realization is both power and vulnerability. Power, because it means that your sense of self is adaptable, that it can incorporate new tools, prosthetics, experiences. Vulnerability, because it means that same adaptability can be hijacked, bent, manipulated, that your body, your sacred, personal shell, can be overwritten by suggestion and circumstance. Philosophically, this shakes the ground beneath the idea of a stable self. If you can mistake a rubber hand for your own, what else might you be misidentifying? What emotions, memories, or roles have you absorbed, simply because the inputs were aligned? Because the timing, the cues, the context all pointed in a certain direction. The illusion is not just physical, it's psychological. You learn not just how the brain binds sensation, but how easily it builds belief. That ownership is not static, but inferred. And that inference is subject to pressure, to suggestion, to the soft coercion of what makes the most sense in the moment. There is also a deeper emotional layer here. One that speaks to loneliness, empathy, even trauma. Some researchers have explored how the rubber hand illusion might relate to disorders of body image, or to conditions like depersonalization, where individuals feel detached from their own body. Others have asked whether this illusion could help prosthetic users integrate artificial limbs more fully, or allow stroke victims to regain a sense of connection to affected limbs. The illusion isn't just a trick. It is a tool, a way to tap into the fluidity of the body's schema and potentially rewire it for healing. And yet, it also opens dark possibilities. Could this same mechanism be exploited to make people identify with systems, ideologies, or digital bodies not their own? In a world where the line between the physical and the virtual grows ever thinner, where VR and brain, computer interfaces extend the self into new domains, the rubber hand illusion becomes more than a curiosity. It becomes a warning that embodiment is vulnerable, that presence is programmable, and yet there's a kind of tenderness in the illusion too. A reminder that your brain, for all its complexity, is simply trying to make you feel whole. It integrates because you need to feel complete. It binds visual and tactile inputs not to fool you, but to preserve your sense of being. It's a testament to how much your mind values coherence, how it would rather extend the self into plastic than let you feel fragmented. And in that gesture, there is something deeply human. You want to belong to your body. You want your sensations to make sense. You want to look at your hand, even if it's not yours, and feel that it is you, because being embodied is not just biological, it is existential. You need a body not just to move, but to mean. And when the illusion works, it gives you that meaning, even if it's built on nothing but aligned strokes and visual trickery. So you sit there, watching a rubber hand being stroked, feeling the touch where it cannot truly be. And you realize the boundary between you and not you is not a wall but a membrane. It breathes, it shifts, it listens. And sometimes, when vision and touch speak in unison, it opens, and you step through into a version of yourself you didn't know you could become, into a new definition of what it means to have a body and what it means to be one. The illusion ends. The experiment stops. But the insight lingers that you are not merely a body experiencing the world. You are the experience itself, flexible, fragile, and endlessly reconfigurable. Phantom limb sensations. You wake up from a surgery, or perhaps from an accident, or maybe you've been living with this absence for years. But one thing remains constant. You feel something that is no longer there. Your arm, your hand, your leg, your foot. It has been removed, amputated, taken from your body by trauma or necessity or illness. And yet, it insists on existing. You feel an itch on fingers you no longer have. You sense your toes curling, even though they no longer lie within any shoe. You reach for a glass with a hand that no longer exists, or feel your missing limb resting heavy on your lap. Sometimes it's mild, a ghost of movement. Other times it's excruciating, burning, stabbing, crushing, pain that originates from nowhere, but spreads everywhere. This phenomenon, both poetic and painful, is called phantom limb sensation. And it forces you to confront the unsettling truth that your brain holds onto parts of you even after your body lets them go. It's not madness, not a delusion, not a weakness of will. It's the logical continuation of a deeply biological truth, that your mind is not just aware of your body, it contains it. Mapped inside your brain, within the folds of the primary somatosensory cortex, lies a representation of every part of your physical form. Each finger, each toe, each cheek and jaw and shoulder, all encoded in a distorted but functional topographical layout, often referred to as the sensory homunculus. And when a limb is lost, that neural representation doesn't simply disappear. The brain doesn't delete it. It clings to it, continues to send signals to it, continues to wait for responses, and in that gap between expectation and feedback, the phantom is born. You don't imagine your missing limb, you feel it as truly and vividly as you feel what remains, because your body exists not just in flesh and nerve, but in memory, in circuitry, in sensory echo. This echo is not always silent. Sometimes it screams. For many, phantom limb sensations evolve into phantom limb pain, where the missing limb becomes a site of agony, despite its absence. The pain can be localized. The fingers feel like they're being crushed, or abstract, a vague burning where my shin should be. It might come and go, or persist like a second heartbeat. The pain is real, even though its origin defies logic. And this paradox of pain in an absent body part has haunted both patients and scientists for decades. Early theories proposed that nerve endings at the amputation site, called neuromas, were misfiring and sending false signals to the brain. Others suggested psychological causes, a form of trauma, grief, or denial. But over time, neuroscience began to uncover something more intricate, more elegant, and more disturbing: that the brain, when deprived of normal input, begins to reorganize itself. In a process called cortical remapping, the brain's map of the body undergoes structural changes when a limb is lost. Nearby regions in the brain's sensory cortex begin to invade the now unused area. For example, the region that once processed hand sensations may be taken over by the area that processes the face. As a result, touching the cheek of someone with an amputated arm might cause them to feel the touch on their phantom fingers. The brain is not passive in the face of loss, it adapts. But sometimes, that adaptation comes at the cost of coherence. The map is redrawn, but the ghost remains. You are left with a sensation without a source, a feeling without a form, a limb that lives on not in tissue but in perception. This phenomenon forces you to question the boundaries of the body. Where does you end? If you can feel what is no longer physically there, is the body truly defined by its current anatomy, or is it defined by the mind's memory of what it used to be? The phantom limb is not just a medical curiosity, it is a crack in the mirror of embodiment, a reminder that your experience of having a body is not entirely governed by what your body is, but by what your brain expects it to be. And expectation in the world of the nervous system is everything. Your brain is a predictive machine, constantly generating models of reality, not just of the external world, but of your internal form. When a limb is lost, the prediction system continues to generate outputs for that limb, to send motor commands, to anticipate feedback. And when no feedback arrives, the discrepancy creates dissonance. The phantom is not a hallucination, it is a prediction error, a symptom of the brain's refusal to accept change, of its desire to maintain continuity. And in that refusal, in that longing for a lost limb, there is something deeply human. You grieve not just the body you had, but the sensations that tethered you to it. You ache not just in pain, but in absence. But not all is suffering. Research has also uncovered strange and beautiful ways to reduce phantom limb pain, not by medication, but by illusion. One of the most famous techniques is mirror therapy, pioneered by neuroscientist V.S. Ramachandran. The method is simple. The patient places their remaining limb into a mirrored box, so that its reflection appears where the missing limb would be. When the patient moves their intact limb, it looks as if the phantom limb is moving too, and sometimes, astonishingly, this visual trick can relieve the pain. The brain, finally seeing movement where it expected paralysis, calms its internal conflict. The phantom limb, no longer frozen in imagined pain, seems to relax. This effect reveals something astonishing, that even pain is not merely a response to damage, but a story the brain tells itself. And if the story changes, the pain can change too. Mirror therapy has led to similar discoveries in virtual reality, where patients see and control digital limbs that replace their lost ones. And once again, the brain adapts. It incorporates, it believes, and in that belief, it finds peace. What does this say about you? That your sense of self, your feeling of having a body, of being whole, is not a passive reflection of biology, but an active simulation, crafted moment by moment in the dark theater of your mind. The phantom limb is the echo of a presence, the refusal of the mind to let go, the persistence of connection beyond physicality, and in that, there is both wonder and warning. Because if your brain can cling to what is gone, it might also fabricate what never was. The same machinery that maintains the ghost of your hand might also create ghosts of belief, identity, trauma. You might carry not just limbs, but losses, not just pain, but presence. Not just what happened, but what was supposed to happen. The phantom limb is a phenomenon of the body, but its shadow stretches into psychology, into identity, into the philosophy of what it means to be whole. And yet, perhaps this persistence is a kind of mercy. Perhaps your brain holds on because it cannot bear abrupt silence. Perhaps it keeps speaking to what is no longer there, because the conversation once mattered. In this way, phantom limbs are not broken code. They are love letters from the nervous system, reminders of where you've been, of what you've lost, of how deeply you once inhabited yourself. The pain may be real, the absence may be sharp, but in that gap, there is also testimony that you were whole once, and your mind remembers that your body may change, but the map of you is not so easily erased. And maybe, just maybe, that lingering echo means you are more than the sum of your parts, that your body, like your life, leaves trails behind, in synapses, in memory, in the invisible architecture of who you are. So you sit quietly and feel your missing hand clench into a fist, or your foot curl toward the floor. You feel it, even though it's not there, and you know now that the feeling is real, not because it comes from tissue, but because it comes from you. From the continuity your brain insists on keeping, from the stubborn way it refuses to forget what once was. And in that stubbornness, there is pain, but there is also beauty, because what you've lost has not vanished. It echoes, it flickers, it lives on, not in flesh, but in feeling. Ames room distortion. You step into a room that looks ordinary enough. 4 walls, a floor, a ceiling, a rectangular frame. Everything shaped to match the architecture you've seen 1,000 times before. A familiar box in which space behaves as it should, where lines converge as expected, and people walking from one corner to another shrink or grow with distance in a predictable way. But then, you notice something strange. A person standing in one corner appears to be twice the size of the person in the other. And when they switch places, they seem to shrink and grow like characters in a surreal animation, their bodies morphing in real time right before your eyes, without any digital trickery, without any sleight of hand. And your brain, wired to believe in consistency, stumbles. You laugh, maybe, or feel momentarily disoriented, because you know they didn't change size. You know the people are the same. And yet your eyes insist. They didn't just move, they transformed. This illusion, this quiet disruption of spatial truth, is known as the Ames room, a space designed to challenge your deeply held assumptions about geometry, perspective, and visual trust. Unlike optical illusions printed on paper or screen, this one surrounds you. It invites you in, and then it betrays your intuition. Because the room, while appearing rectangular, is anything but. The floor is sloped, the ceiling angled, the walls are trapezoids disguised as squares, and the windows and corners carefully constructed to manipulate linear perspective so that your visual system, trained by a lifetime of symmetrical architecture, interprets the space as regular. But it's not. And that misinterpretation causes everything within the room to appear distorted. The shrinking and growing of people inside is not magic. It's a flaw in the machinery of perception, a miscalculation of size and distance born from visual assumptions your brain makes without asking you. You are not seeing what's there. You are seeing what you expect to be there. And what makes the Ames room so powerful isn't just that it tricks your eyes. It's that it reveals how hardwired those expectations are. Your visual system depends on depth cues to interpret the world. Relative size, texture gradients, shadow, motion parallax, convergence, and more. In most environments, these cues work together to give you a coherent, stable sense of space. But the Ames room breaks those cues, not by removing them, but by deliberately rearranging them into a pattern that looks normal but isn't. The slanted walls and skewed angles are designed to neutralize the very clues your brain relies on to understand depth. The result is not confusion, it's confidence. You don't feel like you're in a warped space. You feel like you're in a normal room, and the people inside are physically changing. The illusion is not jarring. It's subtle, persuasive, comfortable. That's what makes it so haunting. It shows you that perception isn't just a reaction, It's a construction. Your brain doesn't merely report what enters your eyes. It builds a three-dimensional model of the world from those inputs, using rules and shortcuts and prior experience. And when those rules are exploited, as in the Ames room, the model fails. But you don't see the failure, you see the illusion. That's the paradox. Your mind lies to you, and it does so with such elegance that the lie feels like truth. You've always trusted your vision to tell you what's real. It's the sense you rely on most, the one you prioritize, the one you turn to when you want to confirm or understand something. But the Ames room teaches you that vision is not an infallible reporter. It's a negotiator. It makes guesses, draws conclusions, fills in gaps. It would rather be coherent than correct. And, in that choice, you begin to see the fragile scaffolding of reality as you experience it. Because if a simple change in room geometry can convince you that a person is growing or shrinking, what else might be shaped, not by the world itself, but by your assumptions about it? What parts of your daily life, the people you judge, the spaces you enter, the stories you tell yourself, are distorted by a hidden architecture, angles you can't see, but that influence everything you perceive? The Ames room is a metaphor for more than just perception. It's a metaphor for bias, for belief, for the invisible frameworks that shape your understanding of truth. And the truth is this: your mind is deeply susceptible to contextual deception. The reason the illusion works is because your brain assumes symmetry. Rooms are rectangular, floors are level, ceilings are flat. People far away appear smaller because of distance, not because they've changed. These rules are so deeply embedded that even when you're told the room is a trick, even when you're shown diagrams or step inside yourself, your brain resists seeing it for what it is. You feel like you should be able to overcome the illusion, but you can't. Not really, because the illusion doesn't live in your knowledge. It lives in your perception, in the neural circuitry that processes vision long before you're even aware of what you're seeing. You can't unsee it because the distortion happens beneath conscious awareness. This isn't stupidity, it's survival. Your brain evolved to make fast, reliable guesses about the world based on partial information. In most environments, those guesses are good enough. But in the Ames room, they are betrayed. And what's more unsettling is that you don't feel betrayed. You feel amazed. You feel wonder, because if a room can lie to you, what else can? If your eyes can be so thoroughly convinced by a false structure, how can you be sure of anything you see? This isn't philosophical doubt, it's a real neurological truth. Your perception is only as good as the context it's built upon, and when that context is manipulated, by design, by culture, by habit, your perception becomes warped. The Ames room is not an isolated anomaly. It's a window into how your brain constructs all experience. You are always standing in metaphorical Ames rooms, situations shaped to feel normal, perspectives that seem level but are slanted, people who appear small or large, not because they are, but because the space around them is tricking your judgment. And just like in the illusion, you don't notice the distortion, you accept it, you believe in it. You trust what the angles suggest, but maybe that trust deserves a second look. Maybe the next time you enter a space, physical or emotional, you pause and ask, are the proportions real? Are the distances true? Or is this another room built to fool your mind into seeing consistency where there is none? Because the most dangerous illusions are not the ones you see on purpose. They're the ones you never question. The Ames room is built to fool you only for a moment. But real life is filled with rooms you live in for years, unaware that the walls don't meet at right angles, that the floor isn't level, that the scale of things has been subtly but persistently skewed. And yet, the beauty of the illusion is that it teaches you something without shouting. It invites you to play with perception, to see how flexible your mind can be. It offers you a moment of humility, a chance to recognize that your senses are not objective instruments, but interpreters, that you don't live in raw data, you live in processed stories, and those stories are vulnerable to architecture, to suggestion, to design. The Ames room doesn't shame you for being fooled. It celebrates your brain's attempt to find order, and in that, it gives you a kind of freedom. The freedom to question, to reframe, to step out of the rooms you've inherited and see the space as it really is. So the next time someone walks across a room and appears to grow or shrink, or the next time a situation feels off in a way you can't quite name, or a person seems smaller than they should, ask yourself, is it them or is it the room? Is it the space that's shifting your judgment? Is the illusion in them, or in the angle from which you see them? The Ames room reminds you that size, scale, importance, value, these are not fixed truths. They are perceptions. And perception is architecture built, bent framed. And if it can be framed one way, it can be reframed another. And maybe that's the lesson worth holding on to, that not everything is as it appears. That sometimes you have to change your position to see clearly. That what looks like magic is often just misunderstood geometry. That what feels small might be bigger than you thought. And what seems massive might just be standing in the right corner. You don't need to demolish the room. You just need to know that its angles can lie. And in knowing that, you begin to find truth, not in what you see, but in how you choose to see. Face blindness. You look someone in the eyes. Maybe someone you love. Maybe someone you've only just met. And you feel that quiet click of recognition, that invisible thread that connects what your eyes perceive to what your memory recalls. A seamless confirmation that this face belongs to a name, a voice, a context, a feeling. But imagine for a moment that this thread was missing, that every face you encountered appeared new, unfamiliar, featureless in its meaning, no matter how many times you had seen it, as though each person existed as a mask without a name, a presence without an anchor, and you begin to grasp the invisible wall of a condition known as prosopagnosia or face blindness, a neurological disorder that strips away your ability to recognize faces while leaving your intelligence, vision, and memory otherwise intact. If you lived with this, you would still see eyes, noses, mouths, but not as wholes that form identities, only as parts without significance. You would smile politely at your spouse in a crowd, but pass them on the street without noticing. You would speak to your boss as if they were a stranger, confuse your child in a classroom lineup, or find yourself reintroducing yourself to a friend you've known for years. Prosopagnosia isn't the inability to see faces. It's the inability to interpret them, to tie them to meaning. And this inability fractures one of the most fundamental mechanisms of human connection, facial recognition. For most people, this process happens effortlessly, in milliseconds, guided by a region of the brain called the fusiform face area, FR, nestled within the temporal lobe. In individuals with prosopagnosia, this region is damaged or underdeveloped, creating a cognitive blind spot where familiar faces should reside. And the result is not confusion, it's disorientation, a constant social vertigo where the familiar and unfamiliar are indistinguishable, and where the world feels like it is populated by strangers, even when it isn't. You might think this would be rare, a neurological quirk affecting only a handful, but in truth, researchers estimate that as many as 2–3% of the population may have some form of face blindness, ranging from developmental cases, present from birth, to acquired forms resulting from brain injury, stroke, or trauma. And many don't even realize it. They chalk it up to being bad with faces or terrible at names, navigating social embarrassment with workarounds. They can't quite explain, recognizing people by hairstyle, clothing, voice, gait, or context instead of facial structure. They become experts in peripheral clues, in scanning for non-facial markers of identity. Some describe recognizing people only when they speak, or only in places where they're expected to be. The cognitive load of such compensation is enormous, and the anxiety it creates can lead to avoidance, isolation, or social withdrawal. After all, how do you maintain friendships when each gathering resets the familiarity you fought to build? How do you move through the world when every encounter is a guessing game? Prosopagnosia doesn't just affect perception, it affects relationships, confidence, trust. It makes something as automatic as eye contact feel like a minefield, and yet, the condition often goes undiagnosed, not because it's subtle, but because people assume it's a personal failing rather than a neurological one. You don't expect a disorder to target something so specific, so foundational, so taken for granted, but it does. And in doing so, it reveals how much of your social world is built on facial constancy, and how much you take for granted your ability to know someone by sight. But what exactly goes wrong in the brain? The fusiform face area is highly specialized for processing faces, not objects, not colors, not general forms, but faces with their unique configurations and expressions. It responds more strongly to faces than to any other category of visual stimulus. In those with prosopagnosia, this region is underactive or impaired. In some cases, especially those acquired later in life, the cause is clear: a lesion, a stroke, a traumatic injury. But in developmental prosopagnosia, the cause is murkier. There may be subtle differences in neural connectivity or genetic factors that lead to reduced specialization of the FFA. Either way, the result is a disruption in the ability to encode or retrieve facial identity. People with this condition might remember details about someone, their job, their voice, their behavior, but not their face. It's as if faces are stored in a different format, a different language, one they were never taught to read. And just as someone with dyslexia might struggle to interpret letters despite seeing them clearly, someone with prosopagnosia struggles to interpret facial identity despite seeing the face itself. This distinction between sensation and interpretation is critical. Face blindness is not blurry vision. It's not poor attention. It's not forgetting. It's the absence of a very specific, very complex process, the mapping of a face to a stored identity. And what this reveals about the brain is profound. That recognition, that tiny flicker of, "I know you," is not a universal function. It is a learned, practiced, neural choreography involving memory, emotion, and perception. It's fast, efficient, and, for most people, invisible. But when it fails, the absence becomes glaring. Without facial recognition, the world becomes fragmented. People blur into one another. Social trust erodes. Conversations feel hollow when you're not sure who you're speaking to. Relationships become fragile when you constantly worry about offending someone by not recognizing them. And in that space, that constant state of uncertainty, grows a deeper kind of loneliness, one where the disconnection is not emotional, but perceptual. You want to connect, you try, but your brain denies you the tools, and so you adapt. You scan for cues. You become hyper-aware of voices, postures, rhythms. You memorize wardrobes, track accessories, read environments like clues in a game. And still, the doubt lingers. Because a face, unlike a voice or a coat, is supposed to be immutable. It's supposed to carry identity. But to you, it doesn't. To you, it's just another shape among shapes. And perhaps that's what makes prosopagnosia such a deeply philosophical condition. It challenges the very notion of what it means to know someone. If you can't recognize a person by their face, what is identity? Is it voice, behavior, context? Is it the feeling they leave you with, the way they treat you, the stories you remember about them? Maybe in the absence of facial memory, you begin to construct identity in other ways, more fluid, more contextual, more experiential. Maybe you come to know people not by static features, but by patterns, impressions, energies, and maybe, just maybe, that's not a deficit. It's a different kind of seeing, a seeing that moves beyond the surface, that is forced to listen deeper, notice more. The world is not built for this kind of perception. It assumes facial fluency. It designs social interaction around it. But when that fluency is gone, new sensitivities emerge. And while prosopagnosia can be isolating, it can also be revealing. It shows you how much others rely on the superficial, and how much meaning lies beyond it. And yet, for many, the emotional cost is real. There is guilt, embarrassment, Shame. People think you're aloof, forgetful, uninterested. They don't understand that you simply don't know what they look like. That your brain doesn't offer that information, that your sense of visual continuity is fractured. Some prosopagnosics keep notebooks of faces and names. Others rely on trusted companions to whisper reminders. Some avoid social events altogether. It's exhausting. Constantly second-guessing your memory, wondering if you've passed by someone important. And over time, this erosion of confidence can lead to real isolation. Not because you lack social skills, but because you fear the moment someone says, "You don't remember me, do you?" And yet, within this challenge lies a kind of profound truth, that identity is not just what we see, but what we feel. That recognition is not just a visual process, but a human one. And maybe, just maybe, living without the automaticity of facial recognition forces you to be more deliberate in how you connect, more attentive, more sincere. You don't assume familiarity, you build it. You don't glide on visual cues. You listen, track, remember through effort. And in that effort, there is something sacred, something honest. Something that says, I may not recognize your face, but I will recognize you, in your voice, in your presence, in the way you make me feel. And so you move through a world where every face is a question, every encounter a puzzle. You learn to live without the thread others take for granted. You build a map not of faces, but of interactions, not of features, but of meanings. And though the path is harder, and though the gaps are many, you walk it with awareness, with the understanding that perception is not infallible, that connection is not always visible, and that knowing someone, truly knowing them, may begin not with the face, but with the heart. Sound-Induced flash illusion. You're looking at a dark screen, a black field with a single white dot near the center. And then, in an instant, it flashes, briefly, cleanly, unmistakably, a short burst of light that enters your eyes and disappears, just as quickly. And along with it, you hear a beep, a high-pitched tone, almost trivial, the kind of sound you wouldn't think twice about in daily life. A microwave alert, a phone's notification, but this time, the sound and the flash occur together, and you feel no strangeness, no disruption. Just a momentary ping of attention, then the sequence plays again. One flash, but two beeps, and this time, something unusual happens. You see two flashes, even though only one occurred, and your brain, so confident, so sure of its own clarity, miscounts reality right in front of you, betrayed not by darkness or confusion, but by the intrusion of a second tone, a harmless beep that restructured your vision without your consent. This is the sound-induced flash illusion, one of the most elegant demonstrations of how tightly coupled and dangerously fallible your senses are, how the sound of something can hijack the way you see, how your brain is constantly stitching together a world not just from what you see and hear, but from how those inputs arrive, overlap, and compete for coherence. You might assume that seeing is believing, that vision holds authority over your other senses, that light leads and sound follows. But this illusion flips that confidence on its head. Here, a sound changes a sight. A beep manipulates a flash, and what you experience is not what happened, but what your brain thinks is most likely to have happened, given the available data, a perceptual compromise that reveals the unsettling truth that you don't see with your eyes alone. In a controlled setting, it's easy to appreciate the illusion. You're told to expect it, to count the flashes, to attend carefully to the pairing of light and sound. But in real life, these mismatches happen all the time, quietly, below awareness, as your brain races to align asynchronous signals into a coherent timeline. Your ears hear faster than your eyes see, not just metaphorically, but biologically. Auditory processing occurs with a latency of around 10 milliseconds, while visual signals often take 50 to 100 milliseconds to reach conscious awareness. That's a small gap in clock time, but a significant one in neural terms. And your brain, unwilling to allow those mismatched arrivals to cause confusion, performs temporal recalibration. It adjusts the perceived timing of events so that they appear synchronized. This works well under normal conditions. But when the illusion is triggered, say, by two closely spaced beeps paired with a single flash, the brain overcompensates. It invents a second flash to match the auditory input. You don't just hear more than you see what you heard. This kind of cross-modal integration isn't optional. It's hardwired into the architecture of perception. Vision and audition don't operate in silos. They influence, modulate, and sometimes distort one another in service of a higher goal: perceptual unity. Your experience of the world is not a stream of raw data. It's a narrative, and when the chapters arrive out of order, your mind edits them for flow. The sound-induced flash illusion is part of a larger family of perceptual phenomena, where one sense dominates another, known collectively as sensory dominance or modality appropriateness. Depending on the context, different senses take the lead. In spatial tasks, vision dominates. In temporal tasks, like detecting brief intervals between events, sound often takes control. That's why a beep can override a flash, because your auditory system is more precise at timing events. The brain leans on the modality that seems most appropriate for the dimension in question. But when those dimensions intersect, as they so often do in real life, errors emerge. You hear something, and it alters what you saw. You see something, and it colors what you heard. The illusion is not a malfunction. It's a feature of how your brain fuses experience. And this fusion is so automatic, so seamless, that you rarely notice it until it fails, until the seams show, and you catch a glimpse of how much of your world is not perceived but negotiated. This illusion has been replicated and studied in countless variations, with different colors, sounds, intervals, shapes, and each version reveals something new about the binding rules of perception. It's been shown that the effect is stronger when the beeps are short, high-pitched, and closely spaced. It diminishes when the sounds are long or low. The illusion can even occur when the beeps are replaced by tactile stimuli, a vibration, a tap on the skin, showing that the integration is not limited to auditory and visual domains. What matters most is timing. The brain operates under a principle of temporal binding, aligning events that occur close together in time to the same cause. This works well when signals originate from the same source, like a person clapping their hands, but becomes problematic when signals come from different sources but are paired artificially. It assumes coherence. It wants coherence, and so it bends time to deliver it. But this illusion is more than a laboratory curiosity. It has implications for everything from interface design to eyewitness testimony. In high-stakes environments like aviation surgery or military operations, small mismatches in audio-visual timing can lead to errors in judgment. A beep suggesting an event has occurred can cause you to believe you saw something that never happened. Similarly, in courtrooms, eyewitnesses often misremember what they saw if it was paired with a suggestive sound or narrative. Your perception of reality is not immune to suggestion, especially when that suggestion comes wrapped in the rhythm of sound. Even in daily life, this plays out. A car horn causes you to see a car in motion that is actually parked. A phone chime leads you to think a screen lit up when it didn't. The illusion isn't just a scientific oddity, it's a blueprint for how susceptible your brain is to conflating senses in pursuit of a stable world. And yet, in that vulnerability lies a deeper kind of beauty. The sound-induced flash illusion doesn't just reveal a flaw, it reveals a strategy. A decision your brain makes to keep your world fluid, aligned, livable. You experience the world not as a scattered barrage of independent events, but as a choreographed dance of moments that feel connected. Your mind curates the inputs, arranges them into plausible sequences, and tells you, this is what happened. You don't hear sounds and see lights separately. You live in an audiovisual tapestry, stitched together in the dark folds of your cortex. And sometimes, yes, that stitching is off. but only slightly and always in service of the bigger picture. Your brain doesn't seek perfection, it seeks coherence. And the sound-induced flash illusion is the cost of that coherence. But what does it mean really? That what you see can be changed by what you hear. That a tone can give birth to light, if only in your mind. It means that reality as you know it is not a direct mirror of the external world. It's a construction. And like any construction, it can be bent, shifted, even momentarily broken. The illusion teaches you humility, that your senses are not sacred, that your perception is not pure, that even something as basic as counting flashes can be warped by an unexpected sound. And in that realization, a deeper truth unfolds. If your senses are this malleable, then so are your memories, your assumptions, your convictions. You are not a passive receiver. You are an active composer. You are not watching the world. You are assembling it. So the next time you see a light flicker and hear two sounds, and your mind insists you saw two flashes, pause. Ask yourself, was it light, or was it expectation? Was it presence, or was it prediction? The sound-induced flash illusion is not just a glitch in perception. It is a glimpse into how perception works, how it bends, adapts, anticipates. And in that glimpse, you are reminded that what you take for reality is more delicate, more flexible, more interpretive than you ever imagined. Your world is not a recording, it is a remix, and the melody of that remix is shaped by what you see, but also, inescapably, by what you hear. Blind spot denial. You look at the world in front of you, a room, a sky, a familiar face, and you trust what you see. Trust that it's complete, continuous, uninterrupted, that your vision is a steady, full-field stream of data delivered straight from the external world to your conscious awareness with no omissions, no dead zones, no silence. But what if that confidence was misplaced? Not because of what you fail to see, but because of what your brain refuses to admit it's not seeing. There is a region in each of your eyes, a very real, very measurable blind spot, where the optic nerve exits the retina, leaving behind a gap with no photoreceptors, no rods or cones to detect light, no machinery to turn photons into perception. And yet, you've probably never noticed it. You've never glanced across a wall or a face or a skyline and seen a hole, a black circle, a missing patch of information. You live your life with two literal voids in your vision, and still the world appears whole. This is not because the blind spot is small or trivial. It's because your brain fills it in, seamlessly, unconsciously, and automatically. And more fascinating still, when confronted with the truth, when you're shown the blind spot with a simple test like the disappearing dot on a screen, you may still resist believing it. You may try to explain it away. This phenomenon, this blind spot denial, is not just about the physical gap in your retina. It's about the cognitive dissonance that arises when your brain's flawless illusion of completeness is exposed as a fabrication. It's the reflexive insistence that I see everything, even in the face of direct evidence that you don't. You're not just blind in a literal anatomical sense, you're blind to your blindness. And that second blindness, the denial, is the more profound one, because it speaks to how deeply your mind craves the illusion of wholeness, and how far it will go to preserve it. To understand this more fully, you have to look at how vision works at the neural level. The retina, the light-sensitive layer at the back of your eye, sends information through the optic nerve to your brain, but at the point where the nerve exits the eye, there's a break in the photoreceptor layer. It's a necessary anatomical trade off, and it creates a small region in your visual field, roughly 5 to 7 degrees wide, where no visual information can be captured. This blind spot exists in each eye, and under normal binocular conditions, the visual field of one eye compensates for the other. But if you close one eye and fixate on a specific point, you can make objects disappear simply by positioning them within that blind spot. Entire letters vanish, lines break, faces distort, and yet, you don't see a black void or a flickering error. You see continuity. Your brain fills the blind spot with surrounding textures, colors, and patterns, creating a perceptual patch so convincing that you're unaware. It's a reconstruction. This isn't a glitch, it's a strategy. The brain abhors absence. It fills gaps to preserve the illusion of an unbroken reality. But here's the twist. Even when you're shown this trick, even when you see with your own eye how the brain fakes the input, you still find it hard to accept that the gap is there all the time. This is the heart of blind spot denial. It's not a denial of anatomy, it's a denial of vulnerability. A refusal to believe that something so central, your sight, is built on missing pieces. And this denial is not limited to vision. It echoes across every domain of perception and belief. Your mind is constantly smoothing over gaps, inconsistencies, and contradictions. Not because it's lazy, but because it's wired for coherence over completeness. In attention, it ignores most of what's happening around you and lets you believe you're aware. In memory, it alters past events to make them fit current beliefs. In hearing, it fills in missing sounds in noisy environments without your awareness. These are not failures. They are the scaffolding of experience. But they come at a cost, a deep, often unacknowledged vulnerability to deception, both from the outside world and from within. The blind spot becomes a metaphor for this vulnerability. It is the literal hole in your perception that your brain conceals with such precision that you deny its existence. And it's this denial, this unquestioned trust in the completeness of your experience, that leaves you most susceptible to illusion, error, and manipulation. Researchers have explored this denial experimentally. When people are shown disappearing stimuli or are made to acknowledge their blind spot, they often rationalize it away. They may claim the object faded or that the test was flawed. Even when the phenomenon is repeated, some still struggle to integrate the fact that their experience is built on fabricated information. This is not stubbornness, it's self-preservation. Your perceptual system is not designed to be fully accurate. It's designed to be convincing. The illusion of an uninterrupted visual world is more useful than the reality of gaps. If you were constantly aware of your blind spots, you would be distracted, disoriented, unable to function, so the brain hides the truth. And when that truth is exposed, your cognitive system resists, not out of ignorance, but out of habit, out of the silent pact between perception and belief that says, what you see is what there is. But now you know that isn't true. You know that at this very moment you're missing part of the world, and your brain is filling it in without your consent. You know that your visual field is not a faithful window, but a curated panorama, and this knowledge, once internalized, begins to shift something deeper. It begins to make you question not just what you see, but what you assume. What else might be missing, hidden behind the smooth veneer of consciousness? What other blind spots has your mind patched over so skillfully that you mistake them for completeness? Your beliefs, your judgments, your memories, your sense of self? If your visual system can fill in a missing patch of wallpaper or the edge of a road without your noticing, perhaps your moral reasoning can fill in missing empathy. Perhaps your identity can gloss over contradiction. Perhaps your story, the story of who you are, contains seams that have been edited so seamlessly that you've never thought to examine them. And yet, there's a strange kind of grace in this too, because it means that your mind is not passive, it's creative, it's active. It builds a world where the gaps are hidden so that you can move, speak, act, love, without falling apart from perceptual dissonance. It protects you, not just from black spots on the wall, but from the existential weight of incomplete knowledge. The blind spot is not a flaw. It's a design decision, a reminder that perfection is not required for beauty, that coherence is not the same as truth, but sometimes it's close enough to carry you forward. And in that forward motion you build your life, moment by moment, impression by impression, on an ever-shifting canvas that you mistake for certainty. So you go on seeing, confident, unaware, the hole in your vision always there, always patched, always absent and present at once. And perhaps that's the final lesson of blind spot denial, that what you don't see isn't always what's missing. Sometimes it's what's been silently supplied. And what you believe about yourself, about the world, about others, may rest not on what's visible, but on what your mind has decided should be there. You are stitched together from guesses, but those guesses are good. Good enough to feel real. Good enough to walk through. Good enough to trust. Until one day, perhaps, the dot disappears, and you realize that reality has always had holes. And still, you called it whole. Optical flow breakdown. You're walking through the world, down a hallway, through a forest, across a crowded street. And with every step, the world around you moves, not as chaos, but as choreography. A constant ballet of shifting shapes and angles, a smooth cascade of motion, where things closer to you glide past faster, while distant objects shift more slowly, all of it processed not consciously, but automatically, seamlessly, in a visual rhythm your brain has trusted since infancy. And yet, what if that rhythm faltered? What if that flow, the subtle, continuous stream of optical change that keeps you oriented, balanced, and alive, were to collapse? Not into darkness, but into a jittery, fragmented dissonance where motion no longer guides you, where the world appears to stop and start in strange spurts, where your sense of direction crumbles into confusion, and your perception of movement breaks into disjointed flashes. This is the disorienting realm of optical flow breakdown, a disruption in one of the brain's most fundamental visual computations, the ability to track motion across space and time, not in objects themselves, but in the field of vision as a whole, a flowing geometry of change that your eyes and brain decode without effort, until something trauma, disorder, over-gen stimulation, or even precise experimental manipulation interferes with the system and reveals just how much your stability depends on motion being continuous. Optical flow isn't something you typically think about. It's not like color, shape, or brightness. It's not even about detecting moving objects, but about sensing the movement of the entire visual field as your eyes, head, and body shift through space. And when it breaks down, it doesn't just confuse what you see, it destabilizes your place in the world. To understand this, you need to look at how your brain constructs motion. Unlike a camera, which records frames passively, your visual system interprets motion by detecting changes in light patterns over time and space, especially those caused by your own movement. When you move forward, everything in your vision flows outward from a central point, known as the focus of expansion. This radial pattern tells your brain not just that you're moving, but where you're headed, how fast, and what's near or far. It's crucial for walking, driving, avoiding obstacles, and even maintaining posture. It's not optional. Without coherent optical flow, you lose your internal GPS. And here's where it gets even more fascinating. Optical flow is processed by specific neural pathways, particularly in areas like the medial superior temporal (MST) area and area V-Phe (MTO) of the visual cortex. These regions decode the flow of patterns, extracting speed, direction, and expansion. They don't care about what you're seeing, but how it's moving. And when that decoding is disrupted by neurological damage, developmental disorder, or artificial interference, the breakdown is not visual static. It's existential displacement. You may still see, but you no longer feel grounded. The world no longer flows. It twitches, jumps, jitters. The harmony is gone. This phenomenon is rare, but well-gen documented. In some individuals with damage to motion sensitive brain areas, such as in the case of achinotopsia or motion blindness, people report seeing the world in frozen snapshots, like a strobe light effect, where motion becomes a series of stills, disrupting even simple tasks like pouring tea or crossing a street. But optical flow breakdown can occur in milder forms too. During high-gen speed virtual reality sessions, overstimulating visual scenes, or certain vestibular disorders, when the brain's integration of movement signals from the eyes and inner ear become desynchronized. You might experience this as motion sickness, visual dizziness, or a vague sense of unreality while moving. You don't feel like the world is spinning, you feel like it's skipping. And in that skip lies a fracture, not in your eyes, but in your trust. The smooth river of motion you unconsciously rely on has become a series of leaks, and through those leaks, your perception begins to drown. And yet, for all its disruption, the illusion of optical flow, when it works, is one of the most miraculous feats of the brain. Every time you move, you generate motion in the visual field. But your brain doesn't confuse this self-generated motion with the movement of external objects. It subtracts your own movements from the scene through a process called reafference, filtering out the flow created by your own eyes and body, so you can see what's actually moving around you. It's a delicate balance. And when that filtering fails, the distinction between self and world begins to blur. You might feel like the environment is moving when you are still, or like you're moving when the world is static. This creates a strange perceptual dissonance, a mismatch between what you expect and what you see. Pilots can experience this during spatial disorientation. Patients with certain neurological conditions report it during seizures, and some individuals feel it during panic attacks or dissociative episodes. Not because their eyes are faulty, but because the integration of motion cues has faltered. But why does this matter? Why does the breakdown of a barely noticeable visual pattern carry such profound effects? Because optical flow isn't just a visual phenomenon, it's a self-orienting system. It tells you who you are in space. It lets you walk, run, turn, lean, and trust the feedback you get from the environment. It underlies your ability to ride a bike, drive a car, or catch a ball. It gives you the feeling of going somewhere, both physically and metaphorically. When that flow breaks, you don't just lose direction, you lose narrative. The story of motion, the unfolding arc of your position in space, becomes incoherent. And in that incoherence, something deeper breaks too. Your confidence that the world will respond to your movement in a stable way. You may begin to mistrust your own steps. You may feel your limbs betray you, or the environment distort. You may freeze, not out of fear, but because your body no longer has the visual cues it needs to move. But perhaps the most profound aspect of optical flow breakdown is what it reveals about your brain's commitment to temporal continuity. You live your life as if time and space are smooth. That one moment flows into the next like water. But this illusion is constantly maintained by the synchronization of multiple systems: vision, vestibular input, proprioception, motor feedback. And when one of those systems lags or misfires or becomes desynchronized, the illusion wavers. You may still see, but you no longer feel present. That's the paradox. Vision without flow becomes alien. The world remains, but your place in it does not. You are left floating, not blind, but unanchored. And yet, there's a strange beauty in this fragility. Optical flow, despite its complexity, is invisible when it works. Like trust, like rhythm, like breath, you only notice it when it's gone. And when it falters, you're reminded that your perception of motion is not a given. It's a gift, a fragile alignment of light, time, and neural inference that lets you move not just through space, but through meaning. Without it, you don't just lose coordination, you lose continuity. The thread that connects who you were a moment ago to who you are now begins to fray. And that thread is not physical, it's perceptual. It's stitched from millions of silent calculations your brain performs without you ever asking. So the next time you walk, and the world glides past you in that quiet, predictable ballet of expansion and contraction, notice it. Feel the invisible flow. The way nearby trees rush by while distant hills drift slowly. The way the ground beneath your feet shifts backward as your body moves forward. This is not decoration, this is orientation. This is the mind telling you, you are here, and you are moving, and the world is responding as it should. But remember, if that flow ever stutters, if the dance falters and the rhythm breaks, It's not because the world is wrong. It's because something deep within the engine of perception has skipped a beat. And in that skip, in that tiny crack in the illusion of seamless movement, you glimpse the scaffolding beneath your experience. You glimpse what it means to see not just with eyes, but with motion. And you understand that stability is not the absence of change. It's the harmony of flow. Motion Aftereffect illusion. You stare at a waterfall, or a scrolling screen, or a rotating spiral, anything that moves in one steady direction for long enough. And you let your eyes follow it. Let your mind sink into the repetitive rhythm, the downward pull, the leftward spin, the illusion of something steady happening outside you while time slows slightly inside you. And then, when the motion stops, when the image freezes, something unexpected happens. The world appears to move in the opposite direction. Not violently, not jarringly, but unmistakably. The static wall seems to rise. The motionless spiral begins to curl the other way. Your brain sees something moving where there is nothing at all. This phenomenon, subtle yet deeply strange, is called the motion aftereffect. And it exposes not just a trick of the senses, but a profound insight into how your mind processes movement, adapts to change, and constructs the ongoing illusion of a stable reality. You are not simply receiving the world, you are constantly recalibrating your perception of it. And sometimes that recalibration leaves an echo, a perceptual ghost that lingers after the stimulus is gone. The motion aftereffect is that ghost, and it's more than just a fleeting illusion. It's a demonstration of how deeply your brain relies on neural adaptation, how it prioritizes contrast over constancy, how it is tuned not to static information but to change, and how even the absence of motion can feel like movement when your internal baselines have been reset by prolonged exposure. This effect is often called the waterfall illusion, because that's how it was first formally observed. By staring at a cascading sheet of water, then turning to the adjacent rock wall and watching it appear to flow upward. But the principle applies to any prolonged motion. Watch traffic flow in one direction, then glance at the sidewalk. Scroll rapidly down your phone for a few minutes, then pause. The content may appear to drift upward. The illusion arises because of how motion-sensitive neurons in your visual cortex, particularly in area vaphae, also known as MT middle temporal visual area, adapt to continued stimulation. These neurons are tuned to specific directions of motion, and when they fire for an extended period in response to a consistent stimulus, they begin to reduce their output, a process known as neural fatigue or adaptation. Once the stimulus stops, the adapted neurons are less active, while their counterparts tuned to the opposite direction remain at baseline. This imbalance creates the illusion of motion in the opposite direction. You're not seeing motion in the world. You're experiencing an internal rebound, a perceptual tilt caused by differential neural activity. And what's striking is how convincing it feels. You know the wall isn't moving, you know the text on your phone is still, but your brain delivers motion anyway, as if unable to stop compensating for a world that has already changed. What this reveals is that your experience of motion is not derived solely from the physical movement of objects in space. It's a comparison process, a continuous balancing act between neurons that respond to different directions. Motion is relative, and your brain is always asking, what direction now compared to just a moment ago? In the motion aftereffect, the moment of comparison has shifted. You're not measuring new input, you're experiencing the residue of adaptation. It's like stepping off a treadmill and feeling the floor move beneath you, or being at sea and sensing the ground sway long after you've returned to land. These are all examples of sensory aftereffects. But the motion variant is particularly instructive because it shows that even fundamental aspects of your visual reality are dynamic, constructed, and susceptible to context. You don't just see movement, you feel what movement should be based on what it was. Your brain has a kind of inertia, and when the stimulus disappears, your perception doesn't stop immediately. It coasts. And in that coasting, you glimpse the fluidity of your visual system. And perhaps more importantly, you glimpse how much of your reality is based on contrast, rather than absolute value. Your brain isn't interested in stable signals. It's tuned to differences, to deltas, to the moments where change occurs. That's why you stop noticing a smell after a while. That's why background noise fades. That's why the ticking clock disappears until it suddenly stops. Sensory systems adapt to the constant, so they can focus on the variable. Motion after effects are the visual echo of this adaptive priority. Your neurons reset their baseline to the ongoing stream of motion. And when it vanishes, they don't reset immediately. They tip you toward the opposite direction, like a pendulum swinging back to center. But what's fascinating is that this swing feels like truth. It doesn't feel like an error or a void. It feels like the world itself is moving, even though you know it isn't. This is the elegance of perception, and its danger. Because what feels real isn't always what's there, and what's there isn't always what you feel. This principle doesn't just affect what you see. It permeates cognition, memory, emotion. When you experience something intensely, a long period of silence, of chaos, of repetition, your brain adjusts. And when the stimulus ends, you feel its opposite. After a day of noise, silence feels deafening. After a long sprint, standing still feels like drifting backward. The motion after effect is a model for how your entire mind processes experience, not as isolated moments, but as gradients of change. You are always comparing the present to the recent past. You are always anchoring now to before. And when the anchor shifts, your experience shifts with it. Even in rest, your mind moves. Even in stillness, it remembers motion. And this raises profound philosophical questions. If what you see right now is influenced by what you were just looking at, then what is perception? Really, is it a mirror of the present or a memory of the past? Is it reality or momentum? The motion after effect shows that your brain isn't waiting for input. It's constantly generating output based on internal dynamics. It expects, predicts, balances, and sometimes those expectations manifest as percepts. You're not hallucinating, you're extrapolating. You're watching the shadow of the world that just was, and mistaking it for the world that is. And yet, within this fragility, there is also a kind of mercy. Adaptation is not a failure, it's a form of efficiency. Your brain cannot attend to all things equally. It must prioritize change. It must reduce noise. It must learn to ignore the constant, so it can respond to the novel. Motion after effects are the cost of that optimization, tiny glitches in the pursuit of perceptual harmony. But they also offer something deeper, a glimpse of the self-correcting machinery beneath your awareness. The algorithms that adjust your senses, not just to detect the world, but to make it coherent. And perhaps coherence, not truth, is the highest goal of perception. You're not built to see everything. You're built to see what matters, and what matters most is what's different from what came before. So the next time you stare at a spinning spiral, or a scrolling feed, or a flowing stream, and then turn your gaze away and watch the world shift, remember this: the illusion isn't in your eyes. It's in your assumptions. It's in the silent inertia of perception. The way your brain tries to keep up with change by anticipating its reversal. The motion after effect isn't a trick. It's a window into your mind's attempt to stay balanced in a moving world. And when that balance lingers into the stillness, it's not because something is wrong. It's because your brain is still dancing with the motion that was, still swaying to the rhythm of moments already gone. You see the afterimage, not because you're confused, but because you were paying attention. And maybe that's what perception is. The slow, beautiful echo of what just passed, painted briefly across the canvas of what now is. Depth inversion. You look at an image, or a face, or a room lit in just the right way, and something inside you shifts. Not dramatically, not loudly, but just enough to unsettle your certainty. Because what should be bulging outward now seems to cave in, and what should be recessed now juts toward you with a quiet wrongness that your mind struggles to correct. And for a moment, you are not sure whether the world is being deceptive or whether your brain is. And in that brief suspension, you experience something called depth inversion, an illusion where the brain flips the depth of a scene, reversing the relationship between foreground and background, convex and concave, inside and outside. Not because of a trick, but because of the way your visual system, so reliant on lighting, shadow, texture, and experience, sometimes misinterprets the simplest clues about three-dimensional structure. What you see is not what's there, but what your brain believes is most likely to be there. Based on context and past experience, a hollow mask appears to protrude. A sculpture seems to turn toward you when it's actually facing away. A crater on the moon flips into a dome, and even though part of you knows this is wrong, even though rationality pulls in one direction, your perception stubbornly insists on another. Depth inversion reveals that three-dimensionality, that deep sense of what is near and far, forward and back, isn't something you see. It's something your brain infers. To understand this, you need to know that your eyes are only capable of receiving two-dimensional projections of the world. Each retina captures a flat image, and it's the brain's task to reconstruct depth using cues. Some from within the image itself, and others from how the two eyes' views differ slightly. This process is called depth perception, and it relies heavily on assumptions, such as the way light usually comes from above, or that shading on the lower edge of an object suggests bulge, not depression. These are not conscious beliefs. They're built in priors, evolutionary shortcuts developed from generations of interacting with a physical world where light mostly comes from the sun, and shapes generally conform to expectations. But when those expectations are violated, when lighting is inverted, when shading is ambiguous, or when context is stripped away, your brain can flip its interpretation. The inside of a face becomes an eerie extrusion, a dent becomes a bump. This isn't about visual failure, it's about perceptual probability. The brain doesn't aim for accuracy, it aims for plausibility. And when ambiguity arises, it chooses the most familiar explanation, even if it is wrong. That's why a hollow mask doesn't look hollow. That's why a concave surface flips to convex. The illusion is strongest when context is weak. In low lighting, monochrome scenes, or artificial displays where typical depth cues are stripped away. And once you're told what's happening, it becomes even stranger. Because even with awareness, you can't override it. You know the face is concave, you can see the shadows, the physics, the engineering, but still, it pops outward. You walk around it, and it follows you, not because it is watching, but because the inversion flips as your angle changes, maintaining the illusion of presence. This is called perspective invariance. And it is another way your brain tries to preserve depth assumptions, despite contradictory input. What you realize in those moments is that your perception of space is not anchored in your eyes, but in your model of the world, a model that relies on symmetry, light, and habit. And when those are disrupted, the model recalculates, sometimes incorrectly, but always confidently. Depth inversion isn't limited to static images. It appears in dynamic environments too: virtual reality, holographic projections, architectural illusions. Even in natural settings, under certain angles, cliffs become cavities, hills become depressions, and your footing becomes uncertain. Your sense of balance is partially driven by depth cues, and when they fail, so does your orientation. Pilots, climbers, and divers are trained to recognize this. In aviation, black hole approaches at night can cause runways to appear too close or too far, leading to misjudged landings. Underwater, divers sometimes ascend thinking they're descending, because depth cues are reversed. These are life-threatening examples of a fundamental truth. When depth fails, so does judgment. And what's haunting is that you often don't know it's failed, because the inversion feels real. That's the trick. The brain doesn't present you with uncertainty, it presents you with an answer. And when that answer is wrong, you rarely notice, because it's delivered with confidence. But there's a deeper implication to this, not just about space, but about assumptions. Depth inversion shows you that your brain always makes a leap from data to belief. It sees flatness, shadow, and disparity, and constructs solidity, proximity, and form. And this leap, though necessary, opens the door to error. You don't see the world as it is. You see it as a best guess. And when that guess is wrong, your entire experience shifts. You feel movement where there is none. You feel nearness where there's distance. You feel reality invert, and you can't stop it. That's humbling, because if your brain can flip depth without your consent, what else can it flip? Intention, emotion, memory, identity. If it can take a hollow face and make it convex, could it take a harmless glance and make it threatening? A neutral tone and make it cold? A passing comment and make it personal? These are not far-fetched questions. They stem from the same principle, that your mind fills in gaps, not with facts, but with expectations. And sometimes, those expectations are upside down still. There's something beautiful in that vulnerability, because it means your perception is alive, not fixed. It's responsive, dynamic, interpretable. It means you're not locked into the raw feed of photons hitting your retinas, but are instead engaged in a conversation with the world, constantly negotiating what's real, based on context, learning, and intuition. Depth inversion is one of the rare moments where that conversation slips and you glimpse the scaffolding beneath. You see the guess instead of the ground. And when that happens, it's not just visual, it's existential. You realize that certainty is often built on illusions you didn't know you were having, that the solid, structured world you move through is partly constructed from neural habits. Habits that can be wrong, but still feel right. And so the next time you look at something and feel that strange pop, that shift where the inside becomes the outside, where a curve turns itself inside out, where something supposed to recede suddenly leans toward you, don't just marvel at the illusion, reflect on what it means, that your sense of space, of depth, of dimensionality is not guaranteed, that it can bend and flip and mislead, that your brain is not showing you what is, but what it believes ought to be. And in that belief lies both danger and grace. Because sometimes the inversion is wrong, and sometimes it reveals a new way to see, a hidden symmetry, a deeper structure, a truth you couldn't perceive until the surface turned inside out. Delboeuf Illusion. You sit down to eat, and in front of you are two identical portions of food. Same size, same shape, same color, same everything. But one is served on a small plate, and the other on a much larger one. And without even thinking, without consciously deciding, you feel it. The one on the small plate feels fuller, more generous, more satisfying, while the one on the large plate looks meager, insufficient. Even though rationally, mathematically, they are the same. And this silent distortion of perception, this quiet trick of context and contrast, is known as the Delboeuf Illusion, a fascinating optical phenomenon that demonstrates how easily your mind can be manipulated by surrounding space, how judgments of size, proportion, and value are never made in isolation, but are always shaped by what surrounds them, by what frames them, by what you compare them to without realizing it. First described by the Belgian philosopher and psychologist Joseph Delboeuf in the 19th century, the illusion appears simple on the surface. Two identical circles, one enclosed by a larger ring, one by a ring closer in size, yet the inner circle surrounded by the larger ring appears smaller than the other, even though both are, in fact, equal. And this misjudgment is not a defect in your vision, but a feature of how your brain processes relative size. You are not a passive receiver of visual facts. You are a relational interpreter. Your mind doesn't measure things in absolute terms. It measures them in contrast. In context against backgrounds and surroundings and silent reference points you don't even notice are there. And this tendency, this cognitive habit of framing, doesn't just apply to circles on a page or food on a plate. It applies to how you evaluate your life, your worth, your happiness, your success. You are constantly judging yourself not by what you are, but by what surrounds you. You feel poor not because you lack, but because someone next to you has more. You feel small not because you are, but because someone else looms larger beside you. The Delboeuf illusion is not just visual, it's existential. Scientifically, the illusion taps into what researchers call surround modulation and contextual influence on size perception. Deeply rooted mechanisms in the visual cortex, especially in the primary visual areas, where signals from the retina are interpreted. Neurons in your brain don't just respond to the light from a shape, they also respond to the contrast between that shape and its surrounding elements. When the surrounding ring is much larger, the brain interprets the central circle as smaller, as if it were farther away or less significant. This is because your visual system evolved not to give you objective measurements, but to help you survive. And in nature, size rarely matters alone. What matters is size in relation to what's around it. Is this fruit bigger than the others? Is that animal larger than you? Is this shadow getting closer or staying far? These are relational questions, and your brain, shaped by millions of years of trial and error, answers them not with perfect rulers, but with quick, heuristic guesses that prioritize speed and pattern over precision. And those guesses, while helpful in the wild, can be misleading in modern life. In supermarkets, in restaurants, in mirrors, in social media feeds, where every post, every body, every vacation photo becomes a larger ring surrounding the little circle of your own experience. Modern research has explored the Delboeuf illusion in diverse contexts, from marketing and nutrition to behavioral economics and even body image studies. For instance, portion control strategies often use this illusion intentionally. Serving smaller portions on smaller plates makes people feel fuller, eat less, and still walk away satisfied. But the implications run deeper. In body image research, the illusion reveals how individuals perceive their own bodies differently, depending on what surrounds them. A person may look in the mirror and feel large or small, depending on the clothing they wear, the lighting, or the people around them. Not because their body has changed, but because their mental frame has shifted. In behavioral economics, the illusion echoes in how we judge prices and deals. A $50 discount on a $300 item feels substantial, while the same discount on a $3,000 item feels negligible, even though the value is the same. Because again, your mind doesn't see $50, it sees $50 relative to something else, and that relativity shapes emotion, perception, and ultimately, decision. But the most haunting aspect of the Delboeuf illusion is how invisibly it operates. You don't feel tricked, you don't feel unsure, you feel confident that the bigger plate holds less, that the smaller circle is larger, that your judgment is right. And this reveals a deeper truth about how much of your certainty in life rests not on reality, but on framing. You believe you're falling behind, not because of any absolute failure, but because the people you compare yourself to have climbed higher. You feel unattractive, not because your features are wrong, but because your mental ring is filled with airbrushed images and filtered standards. You feel old, not because of time itself, but because you're surrounded by youth. And these illusions, unlike the ones on paper, don't fade when measured. They linger, because the measuring sticks themselves are shifting. You change your frame, and the truth bends with it. Neurologically, this is part of what makes the Delboeuf illusion so powerful. The brain's normalization processes, its need to bring input into a relative scale so that it can function quickly and efficiently, are deeply automatic. You cannot unsee the effect just by knowing it's there. Just like a song stuck in your head won't leave simply because you understand the melody. The perception of difference lingers long after logic has tried to explain it away. This is why illusions, all illusions, endure. Because you are not a machine inputting raw data. You are a mind bathing in context, constantly recalibrating, rebalancing, reinterpreting, until you no longer even know what pure perception feels like. The Delboeuf illusion becomes a metaphor for everything you've ever compared. Every time you've looked at your life and thought, not enough, not because it wasn't enough, but because your internal frame, your silent ring, told you it was small. And perhaps that is where the true lesson lies, not in escaping illusions, for you never can fully escape them, but in becoming aware of them, in learning to ask, what ring is surrounding my circle right now? What standard am I measuring myself against? Who drew the border I'm using to define my value, my effort, my progress? The Delboeuf Illusion invites you to pause, to look again, to see how much your dissatisfaction, your longing, your quiet ache comes not from what you have, but from what you think you should have, based on a frame that may never have been yours to begin with. And if you can see that frame, if you can step back and notice the ring, not just the circle, then maybe, just maybe, you can soften the illusion. You can begin to feel full even on a large plate. You can begin to appreciate your life without shrinking it against someone else's. You can begin to see yourself not in relation to others, but in the light of your own steady center, whole, complete, and unmeasured. Tactile illusions. You reach out your hand and touch something, a surface, a texture, a presence, and in that fleeting contact you trust what you feel. Trust that the sensation is true, that the world you are sensing is stable and real and outside of you. But what if that trust is misplaced? What if some of what you feel isn't really there? Or worse, what if what you don't feel actually is? Touch, the most intimate of the senses, the one that anchors you to your body and the objects around you, is not nearly as straightforward as it seems. It is a translation, a construction, a fragile fiction stitched together by the brain, using signals that are incomplete, delayed, filtered, and sometimes, astonishingly, entirely fabricated. Welcome to the strange world of tactile illusions, where pressure becomes motion, where one finger feels two, where warm turns cold, and cold turns burning, and where the borders of your own skin can be rewritten without your consent. It's a world where the act of touching is less about the world itself, and more about what your brain expects, predicts, and decides you should feel, a phenomenon both unsettling and profoundly poetic. Because if even your own skin lies to you, what hope is there for certainty in anything else? Scientifically, tactile illusions are among the most revealing windows into how perception works. They show us that touch, like sight or hearing, is not a passive reception of raw data, but an interpretive process, active, fallible, and deeply tied to context, expectation, and internal models. Take the cutaneous rabbit illusion, for instance. A person receives a series of rapid taps along their forearm, first at the wrist, then mid-forearm, then near the elbow. Although the taps only occur at those three distinct locations, the brain fills in the gaps, and the person often feels the sensation, hopping evenly along the arm, as if a rabbit were bouncing from point to point. Why? Because the brain assumes continuity, smooth motion, and causality. It doesn't register gaps, it interpolates. The physical stimuli are discrete, but the experience is seamless, crafted by the mind to feel real. Or consider the thermal grill illusion, where alternating warm and cool bars are pressed against the skin. Instead of feeling warm and cool simultaneously, people often report a painful burning sensation, a phantom heat that doesn't exist. This illusion taps into how thermoreceptors and nociceptors, pain receptors, interact in the nervous system. The combination of signals, though harmless, is misinterpreted by the brain as a danger signal, triggering a burning pain that is chemically and physically false. The pain is real, but its cause is not. The illusion hurts, but it comes from nowhere. And then there's the Aristotle illusion, where you cross your fingers and touch a small spherical object, like a marble. You will often feel two distinct marbles. Not one, because the crossed position of the fingers tricks the spatial map in your brain, confusing what is inside and what is out, what is one object and what is two. These illusions don't rely on suggestion or imagination. They persist even when you know they're illusions. That's what makes them powerful. Knowing does not stop you from feeling. Your cognition and your perception live in separate rooms, and sometimes they don't speak. This is particularly evident in the phantom touch illusion, often reported in virtual reality environments, where a person feels touch on parts of their body even when there is no physical contact, only visual or simulated feedback. VR researchers have found that when a virtual hand approaches your virtual body in just the right way, even without any real-world touch, the brain sometimes generates the sensation of being touched. It's a neural conjuring trick, where expectation alone is enough to create a somatic experience. Your body reacts to what the mind believes will happen, not just what does. Neurologically, all of this comes down to how the brain integrates somatosensory input. Signals from skin, muscles, joints, and internal sensors, and builds a coherent body schema, a mental model of your physical self in space. But this model is predictive, not photographic. It guesses. It fills in gaps. It smooths inconsistencies. When the predictions are off, when the incoming data is odd, ambiguous, or manipulated, the illusion emerges. And these illusions reveal a hidden truth. Your sense of your own body is not fixed. It can be altered, distorted, expanded, or shrunk. Studies have shown that people can be tricked into feeling a rubber hand is their own, the famous rubber hand illusion, closely related, or that their body is stretching unnaturally in size, or that parts of them are missing entirely. Touch is not just physical, it is profoundly psychological, and it teaches you that you do not live in your body as a fact, but as a story. One the brain is constantly writing and rewriting, with or without your awareness. But beyond the science, beyond the nerves and synapses and cortical maps, there's something quietly philosophical about tactile illusions, something that touches the soul as much as the skin, because they show you how even your most intimate experiences can be constructed. You don't just see the world, you feel it. You feel pain, warmth, closeness, pressure, pleasure, softness, danger. You feel love through a hand held, safety through a blanket, connection through a hug. You think of touch as pure, direct, real. But what if even that is mediated? What if what you think of as closeness is a guess? A neural hallucination calibrated by prior experience and context? What if the warmth of someone else's hand is partly memory, partly projection, partly metaphor? These illusions force you to ask, when was the last time you touched something real? Or were you only ever touching the idea of it? In a world increasingly detached from direct contact, with digital screens, with synthetic interfaces, with haptic feedback replacing true texture, tactile illusions become more than curiosities. They become warnings. If the brain is so easily fooled, what happens when the environment gives it less and less to work with? As artificial touch advances, robotic skin, virtual touchpads, deepfake haptics, will you still know what is real? Or will your fingers adapt and accept the illusion? Will a synthetic handshake feel the same as a real one? Will a simulated caress on your VR avatar trigger the same warmth in your chest as your mother's hand once did, when you were a child with a fever? The line between what is sensed and what is true is already blurring. Tactile illusions are not anomalies. They are the future and the past, and they whisper to you something deep, that the world you inhabit is only partly out there. The rest, perhaps the most important parts, are happening inside, woven together in the quiet space between nerve and meaning. And maybe that's not so bad. Maybe there is something beautiful in knowing that your sense of touch, the very thing that connects you to the physical world, is also the gateway to your imagination. Maybe illusions are not failures, but doorways. Maybe the fact that your brain can feel a touch that never happened means that your capacity for empathy, for connection, for memory is larger than you realized. Maybe the boundary between you and the world was never a wall, but a veil, soft, permeable, shifting with attention. And in that veil, through it, your mind does something magical. It makes you believe you are real, that your body is here, that the ground is solid, that the touch is true. And even if it isn't, even if it's all built on guesses and glitches, it's yours. It's how you navigate. It's how you know you're alive. Cross-modal perception errors. You don't just see the world, or hear it, or smell it. You perceive it through a symphony of senses playing at once, their signals braided into a single fabric you call reality. And yet, what you experience isn't the raw sum of those signals. It's a constructed melody, a fused perception, woven together by a brain trying to make sense of chaos. And in that process of weaving, it sometimes makes mistakes, strange and invisible ones you rarely notice, until the seams show. This is the world of cross-modal perception errors, a subtle and fascinating window into how your senses don't operate in isolation, but in intimate collaboration. How what you hear can change what you see, how what you feel can color what you taste, and how your entire experience of the present moment is a fragile agreement between competing sensory data streams, moderated, smoothed, and occasionally distorted by your brain's best guesses, meaning that your experience of the world is not just filtered but edited, choreographed, fused, and sometimes deeply wrong. To grasp this, imagine sitting in a quiet room, watching someone speak on screen. Their lips move to form the word ga. But what you hear is ba. And your brain, faced with this dissonance, doesn't alert you to the mismatch, doesn't ask for clarification. Instead, it settles the conflict by compromising. It tells you that you heard da, a sound that was never spoken, not audibly, not visually, but one that your mind invents to explain away the contradiction. This is not deception, it is resolution. A phenomenon that seems trivial at first, a minor glitch in multisensory processing, yet it opens a door into the profound reality that what you believe is happening is not merely what is happening, but what your brain decides is the most plausible version of events. And when senses disagree, it often rewrites them. This type of illusion, sometimes referred to as multisensory integration error, occurs because your brain has evolved not to process each sense as a separate channel, but to bind them together into a coherent experience. Because life is not a collection of sights, or sounds, or touches. It is a seamless, synchronized stream, and your mind values consistency above accuracy, coherence above truth, unity over purity. This is why what you see can influence what you hear, as in the classic McGurk effect, but also why a simple touch on your skin can alter what you see on a screen, or why the pitch of a sound can change the flavor of a drink. These are not tricks or parlor games. They are real phenomena backed by rigorous neuroscience, and they show that the sensory borders you assume exist between eye and ear, skin and tongue, body and environment, are more porous than you think. Take, for example, the ventriloquist effect, where a voice seems to come from a puppet's mouth. Not the actual source, because the moving lips capture your visual attention and dominate your auditory localization. Your brain prioritizes what it sees and overrides what it hears. Not because the ears have failed, but because the integration algorithm prefers visual grounding, anchoring sound to sight even when the logic is false. Similarly, in the rubber voice illusion, people begin to believe that a stranger's voice is their own if the voice is artificially synced to their speaking movements. A clear case where proprioception and audition are blended to reinforce a self-image, even when that image is manufactured. Or consider the Delboeuf effect, where shapes and sounds are matched across modalities. People overwhelmingly associate the soft-sounding booba with rounded, blobby shapes and kiki with sharp, angular ones. Despite no logical reason for such a match, a linguistic, visual alignment that suggests your brain encodes and interprets qualities like sharpness, aggression, and softness across sensory channels. Not within them, this cross-modal mapping appears to be universal, found across cultures and even in infants, and it implies something deeper, that meaning itself might not be tethered to any single sense, but floats between them, carried by associations the brain has learned to find reliable. But what happens when these associations break down? In certain neurological conditions, such as synesthesia, cross-modal perception becomes more explicit. A person might hear colors or see music, not metaphorically, but literally. Their senses cross-wired, in a way that causes one modality to evoke another, involuntarily. But in cross-modal perception errors, you get a subtler version of this, less dramatic, more common, and more insidious, because it hides beneath your conscious awareness and quietly shapes your behavior. It's the reason food tastes different depending on its color, or why wine judged under red light is perceived as richer or more full-bodied, or why a crunching sound makes a potato chip feel fresher. Even when it's stale, the sensation is not in the chip, it's in the multimodal interpretation of what freshness means, and that interpretation includes sound, texture, expectation, and even memory. Marketers and chefs use this without you knowing, adjusting plate color, ambient music, or container weight to make experiences more satisfying. Not by altering the substance, but by influencing the way your brain assembles multisensory narratives. And this matters deeply, because if your perceptions can be shifted so easily without your awareness, then so can your decisions, your preferences, even your identity. Your self is partially formed through how you interpret the world. And if those interpretations are malleable, then so are you. The implications ripple into technology too. In virtual and augmented reality, engineers work hard to synchronize haptic feedback with visual and auditory cues, because a mismatch, a delay in sound, a slight desync in motion, can shatter the illusion and trigger discomfort or nausea, an effect known as sensory conflict or simulator sickness. This happens because your brain expects sensory harmony, and when it doesn't get it, it protests. Not politely, but viscerally. The same conflict can occur with modern interfaces, such as touchscreens, that give false haptic feedback, or voice assistants that misalign with physical presence. And as these systems grow more immersive, your mind must learn to adapt, recalibrate, and sometimes believe in things that aren't fully real, simply because they almost are. But perhaps the most intimate and haunting dimension of cross-modal errors is not in consumer products or entertainment, but in human relationships. In the way your senses filter and distort not just objects, but people. You hear someone's voice and assume their emotional state from the tone. But what if the lighting changes the way you perceive their face? Or if a subtle scent in the room colors your emotional reaction? Emotions, after all, are multisensory experiences too. You don't just feel sad. You feel cold, quiet, slowed. Gray joy is warm, bright, fast, colorful. Your moods are constructed from cross-modal cues, and they shape how you judge others, how you remember events, how you build your own story. When you recall a moment of deep connection, a kiss, a farewell, a glance across a room, it's rarely tied to just one sense, but to a blend: the light, the voice, the warmth, the music in the background. And when those blendings go wrong, when your brain misattributes emotion or intention based on faulty sensory fusion, misunderstanding arise, and those misunderstandings shape your reality. This is not merely academic. It is human, fragile, and profound. The people you love, the people you mistrust, the feelings you hold, they are all, to some degree, constructed from fused perceptions that you cannot disentangle or even notice unless you learn to listen more carefully, not just to what you hear, but to how your senses combine, how they collaborate to create a version of truth that may not be the only one, or even the right one, but the one your brain has chosen for you. And so, as you sit quietly, perhaps now more aware of the dance your senses perform each moment, you might begin to wonder, how many times today did your brain choose a reality for you, without asking permission? How many of your opinions, your tastes, your judgments were not facts, but fusions, cross-modal stories told by a mind trying to make sense of too much input, too fast, with too few clues? And does that make your experience less valid or more miraculous? Because maybe the real wonder is not that your senses can be tricked, but that they usually agree at all, that you can live in a world where sound, light, pressure, temperature, balance, and motion all speak different languages, and yet somehow arrive at the same sentence: you are here, this is now, this is real. Maybe that sentence is a compromise, a stitched-together illusion, but it is also your bridge to the world. Not a perfect one, but a working one. And in that imperfect synthesis lies your humanity, adaptable, interpretable, fallible, and yet beautifully coherent. You do not live in a raw stream of data. You live in a narrative. Your senses write together, and even when they argue, even when they get it wrong, they are still trying to build a world you can live in. That world may not be perfectly accurate, but it is yours, and that may be the most meaningful truth of all. Tricking your own balance. You don't always know when you're falling, because not all falling feels like motion, and not all stillness is real. Sometimes balance is not a state, but an illusion you actively construct. A sensory agreement you make without conscious consent. Moment by moment, every time you stand, walk, turn your head, or even close your eyes, your sense of equilibrium is less like a gyroscope and more like a negotiation between your inner ear, your eyes, your joints, your muscles, and most subtly, your expectations. And when that negotiation breaks down, when the signals misalign or deceive each other, you can feel yourself tilt in a still room, sway on flat ground, or stumble while perfectly still. Not because the world is thing, but because your mind is, and this phenomenon, known as vestibular manipulation or balance distortion, reveals how fragile your orientation truly is, and how easily it can be tricked, not by elaborate illusions or complex machinery, but sometimes by a gentle spin, a dark room, or the simple mismatch between what your eyes see and what your body feels. Your balance system, or more precisely your vestibular system, is nestled deep within your inner ear, in a tiny fluid-filled structure called the labyrinth, made of semicircular canals and otolith organs that detect rotational and linear acceleration. This system constantly sends signals to your brain about your head's position relative to gravity and how fast or in what direction you are moving. But here's the catch. It doesn't work alone. To maintain balance, your brain fuses vestibular input with proprioceptive data from your limbs and spine, and visual information from your eyes, meaning your perception of balance is a multisensory synthesis, a best guess interpretation of conflicting signals, not an absolute reading. And this means it's ripe for manipulation, especially when those inputs become inconsistent. Imagine sitting in a spinning chair, eyes closed, and suddenly the chair stops. You feel like you are still spinning, not because your body is, but because the fluid in your inner ear, known as endolymph, continues to move, stimulating the hair cells that send the signal of rotation. And your brain believes it, even against the evidence of stillness. Or take the classic Barony chair, used in astronaut training and neuroscience labs alike. Subjects are spun rapidly and then suddenly asked to perform tasks, point to a fixed object, walk straight, or even speak clearly. The results are disorienting, often humorous, but profoundly revealing. Your balance, it turns out, is shockingly dependent on continuous calibration. Take away vision or distort it, and you unravel the whole internal model. The same principle applies in flight simulators, VR environments, and amusement park rides, each one carefully designed to create dissonance between what you see and what you feel, triggering imbalance even when you're motionless. In some cases, motion sickness results, a form of sensory conflict where the vestibular system tells your brain, you're moving, while your eyes report stillness, or vice versa. Your brain, confused by the contradiction, reacts as if something is wrong. Nausea, dizziness, cold sweats, all symptoms of your perception system failing to reconcile, opposing realities. And this isn't just a glitch. It is a protective mechanism, deeply rooted in evolutionary biology in ancient environments. Such sensory mismatches might have indicated poisoning, hallucinogenic plants, or neurotoxins could disrupt balance and perception, so the body evolved to reject them through vomiting. Today, that same system rebels against VR games or car rides. But the inverse is also true. You can intentionally create the illusion of motion or tilt without moving a muscle, simply by manipulating visual input. This is why certain optical flow patterns in video or animation can make you feel like you're sliding backward when you're not, or why IMAX films can induce vertigo. Because your balance is not just about your body's position in space, but your brain's belief about it. Even standing on the deck of a ship after days at sea can feel wrong. Your feet are finally on unmoving ground, but your body still expects the sway of the ocean, and you may find yourself adjusting for waves that aren't there, a phenomenon called mal de débarquement. In short, your sense of equilibrium is not merely physical. It's cognitive, predictive, and vulnerable to error. This becomes even more complex when you consider how balance links to emotion and cognition. Studies show that when people feel anxious or depressed, their postural stability is affected. They sway more, hesitate more, show impaired balance even in simple tasks. And conversely, disorientation can trigger anxiety, panic, and confusion. The two are mutually reinforcing. Balance is thus not just a motor function, but a psychological state, one that reflects and influences your mental landscape. This is evident in patients with vestibular disorders, those with Meniere's disease, for instance, experience random spells of vertigo, leading not just to physical instability, but emotional fear, social withdrawal, and even cognitive fog. To lose your balance isn't just to stumble. It's to lose trust in your body's ability to predict the world. And it is this trust, fragile and largely unconscious, that allows you to move confidently, to navigate crowded streets, to dance, to lean in close without bracing yourself, to reach out without fearing collapse. It is trust that holds you upright, not muscle alone. And when that trust is betrayed, the world itself begins to feel unstable. This becomes painfully clear in aging, where tiny degradations in vestibular feedback lead to real falls, and with them, a loss of confidence that spirals into immobility, isolation, and further decline. To catch yourself when falling is not just a reflex. It's a memory, a prediction, a promise the body makes to the mind. I've got you. But when that promise falters, fear takes its place. Yet, you can trick that system gently, harmlessly, and sometimes therapeutically to learn how it works. Physical therapists use balance boards, foam surfaces, and wobble cushions to train patients with vestibular issues, exposing them to controlled instability to rebuild sensory integration. Children naturally do this too, spinning, hopping, balancing on curbs, all in playful exploration of where their bodies end and the world begins. Even yoga, dance, and martial arts involve continuous calibration of balance through breath, gaze, and micro adjustments, reinforcing the connection between movement and mind. These practices reveal a deeper truth. Balance is not something you achieve once. It is something you maintain through perpetual awareness, micro-corrections, and adaptation. And in a metaphorical sense, your emotional life is much the same. You don't become emotionally balanced and stay there forever. Instead, you learn to feel when you're tilting, when your inner signals don't match your outer world, when something feels off kilter even if everything looks still. And in that moment you pause, you adjust, you recalibrate, and you stand again. So the next time you feel dizzy, either from motion or emotion, remember that what you're experiencing is not failure. It's feedback. It's your body telling you that the world has changed, or that you have, and that your internal model needs updating. Your balance is not a rigid certainty, but a living, breathing conversation between your senses, your memories, and your predictions. And sometimes it can be tricked. But in that trick is a lesson: you are not a static thing. You are fluid, responsive, a system constantly learning how to stand again. And maybe that's not a flaw, but a kind of wisdom, a recognition that staying upright in life or in space requires humility, attention, and the courage to keep recalibrating, even when the floor feels like it's moving beneath you. Vestibular disorientation. You step forward, and suddenly the world feels tilted. Not because it is, but because something inside you no longer agrees with it. As if your internal compass, once precise and quiet, has started spinning without your permission. Like a dancer losing rhythm in a choreography it once knew by heart. Your feet are on solid ground, but your perception says otherwise. And in that silent conflict, the room begins to pulse. The floor feels soft, the ceiling spins, and gravity becomes a rumor instead of a rule. This is vestibular disorientation. Not just dizziness, not just imbalance, but a profound and often invisible unraveling of your inner map of space, motion, and self. It begins deep within the inner ear, in a structure so small it could hide inside the head of a pin, yet so vital it dictates how you know which way is up, how fast you're moving, and where your body ends and the world begins. Nestled in the temporal bone, your vestibular system, composed of semicircular canals, utricles, and saccules, is constantly measuring acceleration, rotation, and the pull of gravity, using fluid-filled loops and hair, like sensors, to tell your brain not just where you are, but how you are moving through space. But this is only part of the story, because balance is not a one-sense operation. It is a negotiation between vision, proprioception, and vestibular input, fused together by the brain into a singular, seamless experience of orientation. And when that negotiation breaks down, when the inputs disagree or degrade or go silent, you don't just feel confused. You feel lost inside your own skin, like the axis of your body no longer lines up with the axis of the world, and movement becomes a question rather than a certainty. Vestibular disorientation is most often discussed in clinical contexts, seen in patients with labyrinthitis, Meniere's disease, vestibular neuritis, or inner ear trauma. But its reach is far wider and more subtle than most realize. It can arise after a long car ride or boat trip, when the motion continues to echo inside you, even after everything else has stopped. It can appear when you wake in the dark and can't tell which way your body is facing. It can show up when you stand too quickly, or when fluorescent lights flicker just wrong, or when a migraine quietly scrambles the sensory routing of your brain. And perhaps most tellingly, it is experienced profoundly by astronauts and pilots, whose relationship with gravity becomes abstract or unreliable, forcing them to rely not on feeling, but on faith in instruments and protocols. A reminder that the vestibular system is not infallible, and when it fails, the world bends with it. It is why disorientation is among the greatest threats in aviation and space travel. Not engine failure, not pressure loss, but the simple confusion between what is real and what is perceived. Even the most experienced pilot can suddenly feel like the plane is climbing when it is falling, turning when it is still, inverted when it is right side up. It's called spatial disorientation, and it has taken down aircraft not because the machine was broken, but because the mind of the pilot couldn't reconcile conflicting signals fast enough to recover. And it reveals an uncomfortable truth, that your perception is always a guess, and sometimes that guess is wrong. But disorientation is not just a spatial failure, it is an existential one. When the vestibular system falters, you don't just lose your place in the room, you lose a quiet sense of certainty that your body knows the world. You feel the floor become unfamiliar, you question your own movement, you begin to distrust the body that used to feel like home, and from that distrust grows anxiety. Not just about falling, but about the stability of your reality itself. Many who suffer from chronic vestibular disorders speak not only of dizziness, but of derealization, the eerie sensation that the world around them has become artificial or surreal, like walking through a dream that has forgotten its rules. And the most difficult part is the spinning. It's the waiting. Waiting to stand without tipping, waiting to move without spiraling, waiting to trust again the silent sense that used to guide you effortlessly through crowds, down staircases, across curbs and escalators and dance floors. Because the vestibular system is not dramatic, it is background, ambient, invisible until broken. like a soundtrack that only becomes noticeable when it skips or distorts, and suddenly, everything else feels off. Beat. Yet within this disarray lies a profound lesson about how the mind and body construct the present. You do not simply receive reality. You assemble it, you cross-reference input from 3 different systems, integrate it into a model, and act on that model with breathtaking speed and confidence, most of the time without realizing it. And when that model glitches, it doesn't just alter your movement, it alters your sense of self. You are not a fixed point in space, but a process, a pattern of predictions and recalibrations that must constantly update based on what you feel, see, and know. And when those don't match, you feel it. Not intellectually, but viscerally, like a singer thrown off key by a discordant note they didn't mean to sing. You try to harmonize again with your surroundings, but the melody escapes you, and the dissonance lingers. And still, you try. Even in the fog of disorientation, your brain is working, reweighing, recalculating, attempting to anchor to any reliable reference point. A wall, a handrail, a voice, a heartbeat. And slowly, sometimes with therapy, sometimes with time, sometimes never fully, the signals realign, or at least you learn to adapt to their new rhythm. For some, the recovery is physical. Vestibular rehabilitation therapy retrains the brain to interpret signals more accurately, using gaze stabilization, balance challenges, and controlled movements to rebuild trust between sensation and action. For others, it is emotional, learning to live with uncertainty, to find equilibrium, not in perfect stillness, but in resilience. Because disorientation is not always something you cure. It is sometimes something you carry, like an old scar, or a memory of falling. But even in that, there is growth. To live through vestibular disorientation is to witness the fragility of perception, and still find your way forward. It is to realize that the world is not fixed beneath your feet, but something you reconstruct. One moment at a time, through faith in your senses and patience with your confusion. And in that reconstruction, in the quiet courage it takes to walk, even when the ground feels fluid, to reach out even when your center shifts. There is a deeper kind of balance, one not granted by the ear, but earned by the will. So if ever you find yourself spinning in stillness, remember, you are not broken, only recalibrating, and the horizon will return, not because the world has stopped moving, but because you have learned how to move with it again. Sensory substitution. You don't need to see to understand space, and you don't need to hear to feel the world's music. What you need is a bridge, a translation, a way for your brain to speak a language it thought it had forgotten. And that is the quiet miracle of sensory substitution, the astonishing capacity of your nervous system to rewrite reality using different inputs, to take vision and pour it through touch, to take sound and weave it into pattern, to reconfigure your perception like a master composer rearranging instruments to play the same symphony, even after some have fallen silent. Imagine a blind person wearing a device that converts images from a camera into vibrations on their back. And over time, those vibrations aren't just sensations. They become doors, walls, trees, even faces, not as metaphors, but as direct perceptions, as real and spatially valid as sight itself. Their brain doesn't just feel the buzz. It sees through it, or someone born deaf who wears a device that turns speech frequencies into subtle electrical pulses on their tongue. And soon, they can hear words without sound, comprehend tone without ears, because the brain is not loyal to the original channel. It is loyal to meaning, and if you give it consistent input and time, it will learn to interpret that input as if it were always meant to be there. And this is not science fiction, it is the daily, lived truth of people using devices like BrainPort, the voice, and sensory substitution systems, still in experimental stages, all built on one profound realization. The brain is fundamentally multisensory, and if one door closes, another can be built, not in the periphery, but in the heart of how experience is constructed. To understand how this works, you have to shift your idea of senses. not as isolated wires plugged into specific regions, but as overlapping maps feeding into a central interpreter, the brainstem and cortex, which do not care whether information comes from the eye, the ear, or the skin. So long as it is reliable and patterned, your visual cortex can process tactile input. Your auditory cortex can adapt to visual rhythms. Your somatosensory areas can integrate sound or light if trained properly. It's all just data. And the brain is a voracious data processor, hungry not for format but for meaning. In experiments, sighted people have been blindfolded and trained to use a camera, to tongue-way interface that delivers spatial information as patterns of tingles on the tongue. And within days, their brain activity shifts. Regions previously activated by visual tasks light up in response to tongue stimulation. It's not imagination, it's not metaphor. It's cortical remapping, a tangible demonstration that perception is not tied to anatomy, but to interpretation. And this adaptability is most vivid in people who lost a sense early in life. Children born blind often show remarkable auditory or tactile spatial awareness. And the same applies in reverse. People born deaf often develop sharper peripheral vision and motion detection, because the brain allocates its resources with astonishing pragmatism. Unused auditory real estate is repurposed for visual processing, and vice versa. But this phenomenon is not just a triumph of technology. It is a window into the plasticity of the human mind, into the silent negotiations your brain performs every second to generate a seamless experience of being. You think you see the world through your eyes, but in truth, you see it through your brain. And your brain is not limited by your body's original blueprint. You think hearing is something that happens in the ears, but it is just as much a construction of cortex, memory, and interpretation. Sensory substitution reminds you that the self you feel, the stable, coherent experiencer behind your eyes, is not fixed, but fluid, an emergent phenomenon built on feedback loops between body and brain. And if those loops change, so do you. A new sensory channel becomes part of your identity, not as an add-on, but as a core feature. And over time, you begin to realize something deeper. You do not inhabit the world directly. You inhabit a model of the world, sculpted by your senses, refined by your attention, and stabilized by routine. And when the senses shift, the model can too, often more gracefully than you would ever expect. There's something almost spiritual about this, about learning to perceive in a way no one else does, about feeling your brain stretch into unfamiliar territory, about watching the known world redraw itself in strange but meaningful textures. It is like learning a new language, but one spoken through the body, a language where door means a pulse on the left side of your back, and face means a curved vibration that widens as someone smiles. And you begin to realize how arbitrary your assumptions were, how sight always seemed essential, or hearing absolute. But now you know they are just one way among many. And this opens up not just possibility, but empathy, because you can no longer assume that others see or hear or feel the same world you do. And that humility is the beginning of real connection. Sensory substitution teaches not just adaptability, but compassion. It reminds you that perception is a privilege, and that even when that privilege is lost, the human mind has ways of reinventing reality from the inside out. This is not to romanticize loss. Losing a sense can be devastating, disorienting, and isolating. It can feel like the world has shrunk, like a curtain has dropped between you and others. But sensory substitution doesn't replace what was lost. It transforms what remains. And that transformation is not second best. It is not compensation. It is reinvention. It is the brain saying, I still want to know, and finding a way to do so. And in this way, people who live with sensory substitution become pioneers of perception, charting inner territory most will never visit, proving with every step that the boundaries of experience are not drawn in flesh, but in possibility. And as technology improves, through haptic interfaces, neural implants, machine learning, enhanced pattern translation, We are beginning to glimpse a future where senses are not just restored, but augmented, where new forms of perception emerge, seeing heat, feeling radio waves, hearing magnetic fields, not science fiction, but a logical extension of what sensory substitution already demonstrates. And this vision forces you to ask, what even is reality if it can be accessed in so many ways? If you can see with your skin and hear with your tongue, is the world truly out there, or is it something you co-create with your nervous system? Is perception discovery or invention? And if the brain can learn to reinterpret vibration as vision, what else could it learn to do? Could we one day feel another person's emotions directly? Could we one day experience memory as spatial architecture? The potential is breathtaking. Not just for those who've lost a sense, but for all of us, because it means that the human experience is not a fixed quantity. It is a palette, an evolving set of tools that can be expanded, recombined, and redefined. And maybe that's the real message of sensory substitution. Not that we can regain what was lost, but that we are always capable of becoming more than we were. That inside each of us is a brain eager to grow, to adapt, to understand, to reach across silence and find structure, across darkness and find pattern, across loss and find meaning. And in that reaching, in that defiance of limitation, lies the most human thing of all. But how fiercely you choose to keep perceiving auditory illusions. You trust your ears, don't you? You assume that what you hear is real, stable, external, factual. But what if sound isn't something you receive, but something your brain constructs, something it guesses and fills in, and even fabricates when it feels the silence growing too wide? Auditory illusions reveal this fragile scaffolding. They are not just curious anomalies. They are glimpses into the architecture of perception, showing you how the brain negotiates with time, space, rhythm, and meaning to build a version of the world you can navigate. Even if that version is sometimes wrong, you hear a repeating word, and suddenly it seems to morph into gibberish. Not because the sound has changed, but because your auditory system, overwhelmed by repetition, begins to reinterpret the signal. This is called semantic satiation, and it reminds you that meaning is not in the air but in your mind. Or consider the shepherd tone, an endless auditory staircase that seems to rise forever, like a sonic optical illusion, always climbing but never arriving, crafted by layering tones separated by octaves, and fading them in and out at just the right time, so your brain cannot locate a beginning or end. Just the unsettling sense of constant motion. Then there's the tritone paradox, where two tones separated by a half octave sound like they're ascending to some and descending to others, depending not on the frequencies themselves, but on the listener's cultural background and even native language, suggesting that perception isn't just biological, but learned, and that your sense of pitch might be shaped by the language you were wrapped in as a child. And the McGurk Effect, though you've heard of it perhaps in a visual context, reminds us again that what you hear can be overwritten by what you see. When the sound of bar is paired with a video of someone mouthing "gar," your brain often hears "da," an entirely new phoneme born not from the ears or the eyes alone, but from their uneasy union. These illusions are not flaws, they are features. They exist because your brain is trying to do something incredibly difficult: extract consistent meaning from fleeting, noisy, overlapping sensory input, often with limited or ambiguous data. And it does so by drawing on past experiences, expectations, and learned templates. Sound doesn't simply enter you. It is decoded, contextualized, shaped into a model, and that model is deeply personal. This is why two people at the same concert may remember entirely different rhythms, why you sometimes hear your name in a crowded room even when it wasn't said, why a sudden silence can sound louder than a scream. Because your brain is constantly making predictions, and when those predictions are violated, you feel the gap not just cognitively, but emotionally. And that's the strange poetry of auditory illusions. They turn your own predictions against you, not to deceive, but to reveal how perception is stitched together from fragments. Take the precedence effect, for instance. a phenomenon where two identical sounds are played in quick succession from different locations, and you perceive the location of the first sound only, ignoring the echo that follows milliseconds later. Your brain decides what counts as the real source of the sound and suppresses the rest because spatial accuracy matters more than strict fidelity. Or the missing fundamental illusion. When you hear complex tones missing their lowest frequency, your brain recreates that frequency internally, giving you the sensation of a bass note that doesn't physically exist, even in music. Auditory illusions are everywhere, in binaural beats, two tones of slightly different frequencies played in each ear. You don't hear either tone directly, but a third, ghostly beat your brain invents in response to the phase difference. The illusion isn't in the ears, it's in the processing. And these aren't just quirks. They are evidence that what you call hearing is a dance between expectation and sensation, between signal and noise, between the real and the imagined. Think about the Zwicker tone after being exposed to a burst of noise with a spectral gap. Listeners report hearing a phantom tone where the gap was, a sound that was never played. The auditory cortex, missing what it expects, fills in the silence with a hallucinated frequency, as if silence itself is too unnatural to endure. And when you consider illusions like phantom words, where looping indistinct sounds begin to sound like actual English phrases, you start to see that your mind doesn't just detect meaning, it projects it, especially in conditions of ambiguity. Your perception is a participatory act, not a passive one. And in the dark, when your visual world shuts down and you rely more heavily on sound, you may notice these illusions more clearly. How the creak in the floor becomes a voice, how the wind outside sounds like someone breathing, how static from a machine seems to hum with secret messages. This is not madness. This is the normal, adaptive, ever-revising orchestra of your perception, tuning itself moment by moment. But it isn't just about illusions you notice. It's about the ones you don't. Every day, your brain is correcting distortions, recalibrating pitch, smoothing over missing information in speech, compensating for background noise, adjusting volume based on context, and all of it happens without your awareness. When someone speaks to you in a noisy restaurant, and you hear them clearly, you're not just hearing their voice, you're unconsciously filtering out other voices, using spatial location, pitch contour, and familiarity to focus attention. A phenomenon known as the cocktail party effect. And when a sound reaches one ear slightly before the other, your brain calculates the difference in microseconds to determine where the sound is coming from, using interaural time differences, a staggering feat of neurological computation happening constantly. Yet you don't feel it as computation. You feel it as effortless presence. You walk through a city immersed in layers of sound, most of which you ignore because your brain has learned to prioritize what matters. You're not aware of the low hum of traffic or the buzz of fluorescent lights until someone points it out. These illusions, these adaptations, are what allow you to focus, to communicate, to survive. But they also remind you that perception is not reality. It is a translation, and translations by their nature are always interpretive. In this way, auditory illusions offer more than curiosity. They offer humility. They remind you that what you hear is not the world itself, but the world filtered through your biology, your psychology, your memory. They show you how easy it is to mishear, to overhear, to hear what was never there, and to miss what was. And they make you wonder, how many things have I misunderstood? Not just in sound, but in life, because I trusted a sense that is always reconstructing the truth. How many arguments, memories, confessions, or silences were shaped not by what was said, but by how I heard it. Hearing is not a passive act. It is creative, emotional, fragile. You don't just process sounds, you are moved by them, haunted by them, changed by them. A lullaby, a scream, a whisper, a laugh. They land in your ears but resonate in your identity. And sometimes, it's not the sound itself, but the absence of it that echoes the loudest. the imagined voice of someone you miss, the remembered cadence of someone long gone, the phantom echo of words you wish you could unhear. Illusions are not errors. They are reflections of how deeply you long to make sense of the world, even when it doesn't make sense on its own. So the next time you hear something strange, something that doesn't seem to match the world as you know it, don't dismiss it. Instead, let it remind you that you live in a beautifully imprecise universe, where your senses are not rulers, but artists, where your ears are not recorders, but translators, and where your experience of sound is not a direct window into reality, but a stained, glass rendering full of color, bias, memory, and meaning. In every illusion, there's a secret that your brain would rather create than remain uncertain, that you are wired not just for truth, but for coherence. And maybe that's what makes auditory illusions so strangely comforting. Not that they fool you, but that they show you how determined you are to understand, even when what you hear was never truly there at all. Temporal illusions. You live your life by time, or so you think. You wake to alarms. You race against clocks. You count hours and measure years, assuming time flows forward evenly, dependably. But what if your perception of time is less like a river and more like a canvas, smeared with brushstrokes of memory, attention, and emotion? What if time, as you experience it, is not dictated by physics, but by psychology, not absolute, but elastic, bent and stretched and stitched together by your brain to tell a story it hopes will make sense? Temporal illusions reveal just how fragile your internal clock really is. Not in the way of seconds ticking, but in the way moments expand, contract, and sometimes vanish entirely. Picture this. You're driving down a highway, and a deer darts into the road. Everything seems to slow down. Details sharpen, and later you swear the moment lasted far longer than it possibly could have. Or imagine seeing a flashing light right after moving your eyes, and feeling impossibly like it had been flashing even before your eyes landed. That's chronostasis, a time-stitching illusion where your brain extends the present backward to fill the gap caused by a saccade, a rapid eye movement during which you are technically blind. But your experience never feels interrupted because your mind erases the blank and overwrites it with borrowed presence. You don't live in real time. You live in a narrative approximation, always slightly behind, always slightly re-edited. And this isn't a bug. It's how consciousness survives its own latency. The very machinery that processes input needs milliseconds to catch up, and to hide the delay, your brain invents a seamless flow. You live in a hallucinated now, padded by guesses and ghost signals, and every second you think you feel is a best effort rendering. Even your memory plays along, distorting durations based on the density of information. New experiences feel longer than familiar ones, because your brain uses the number of stored details to infer how much time must have passed. That's why a vacation filled with novelty feels expansive in hindsight, while a routine week evaporates. It's why childhood summers felt endless and adult years feel compressed. Because time lived is not the same as time remembered. Your inner clock doesn't tick, it edits. But temporal illusions don't stop with memory. They shape your experience of the present too. In experiments, when people are shown a series of identical stimuli spaced evenly apart, and then a different one pops up, they perceive that oddball as lasting longer, even if it didn't. This is called the temporal oddball effect, and it shows how surprise can dilate your sense of duration. The unexpected stretches the moment, like your brain is suddenly pressing record with greater urgency. Novelty grabs more attention, and with more attention comes the illusion of more time. Similarly, when you anticipate something intensely, like waiting for test results, or sitting through a long silence after asking a vulnerable question, time crawls. But if you're immersed in flow, doing something engaging and pleasurable, it vanishes. These aren't just feelings, they're measurable distortions of perceived time, often correlated with how dopamine and attention interact in your brain. Even motion plays a role. When objects speed up or slow down, your sense of their timing shifts accordingly. A moving flash appears to occur earlier than a stationary one shown at the same time. a phenomenon known as the flash, lag effect. And in sports, athletes often describe times slowing down during critical plays, not because their senses are enhanced, but because their focus sharpens so much that the memory of the moment becomes more densely packed. In reality, the clock ticks as always, but your experience of it is molded by emotion, intention, and relevance, and it can be manipulated. Magicians exploit this with misdirection, creating time gaps during which a sleight of hand occurs, and your brain fills in the timeline with something plausible, even if it's incorrect. Films do the same, through editing, pacing, and soundtrack. They bend your perception of time effortlessly, stretching seconds into minutes and collapsing hours into moments. Your mind is pliable, and time is its most elastic canvas. There's also the strange relationship between temporal illusions and trauma. People who survive life-threatening events often report intense time dilation, not because the events took longer, but because their brains recorded so many details that the episode feels enormous in hindsight. It's a survival mechanism. More sensory data means better preparation for future threats, but the cost is emotional residue. Some memories become so dense that they distort future time perception. After trauma, people often report that days feel slower, or that time has lost meaning altogether. Depression, too, skews your internal clock. Seconds seem to drag, future goals feel unreachable, and the past becomes sticky. Conversely, in states of mania, time rushes, your thoughts race, speech accelerates, the hours blur. Time, in all its supposed objectivity, is profoundly tied to mood. Even age changes it. Children often underestimate time intervals because they have less internal calibration, while older adults report that the years pass more quickly, not because they are busier, but because the brain records fewer novel memories with age, and fewer markers means less felt time. This suggests a profound paradox. The more new things you do, the longer your life feels, not in years, but in depth. You can't control the clock, but you can influence the narrative it becomes. You can stretch time not by slowing it down, but by living more within each passing moment. And then there are illusions, so subtle you rarely notice them. The backward referral of awareness, where you become aware of a stimulus after a delay, but your mind time stamps it to an earlier moment. In neuroscience, Benjamin Libet's experiments showed that your brain prepares to move before you consciously decide to, yet you experience your choice as having come first. This rearrangement of time protects your sense of agency, but challenges the idea of free will. You are not just living in a temporal illusion, you are constructed by one. Your sense of self, your sense of decision-making, your awareness of cause and effect, all rely on your brain's ability to create a coherent timeline, even if that means editing reality. You don't just experience time, you participate in its fabrication. And once you realize this, time itself becomes less of a force and more of a question. What does it mean to waste time when its measurement is internal? What does it mean to be late when no two minds feel the same moment identically? When you're waiting for someone to reply and the silence stretches unbearably, is it the clock that hurts you, or your own mind looping through imagined futures? Is the past ever real, or is it a reconstruction of now dressed in yesterday's costume? You begin to see that time isn't something you travel through. It's something you build, like a house, one floor at a time, using memory as mortar and attention as timber. And the illusion isn't in the moment, it's in the belief that the moment is fixed. Yet even in knowing all this, you still live by time. You still count days and celebrate birthdays and mourn anniversaries. Because while your brain distorts time, your heart anchors itself in it. You mark meaning with dates. You tie emotion to duration. You speak of healing with phrases like, "Give it time." Even though healing often unfolds in cycles, not straight lines. Temporal illusions don't just shape your sense of duration, they shape your sense of hope. You believe that pain will pass, because time moves forward. You trust that joy will come, because the seasons cycle. You dream not of eternity, but of a tomorrow that might feel better. And that faith, too, is an illusion, but a necessary one. It gives you the courage to endure slow minutes and the wisdom to savor fast ones. So maybe illusions aren't the opposite of truth. Maybe they are truths told in softer language. Maybe they are reminders that even though the world spins at a fixed pace, you are free to feel it differently, to pause, to stretch, to breathe, and to remember that sometimes the longest moment is not the one with the most seconds, but the one you never forget. Mirror reversal confusion. You stand in front of the mirror, and without even thinking, you raise your right hand. Your reflection lifts its left, and although you've seen this exchange 1,000 times, you've probably never questioned why it happens, or more strangely, why it feels so intuitive and yet so wrong. Like you are looking at yourself but through a lie dressed as familiarity, and the deeper you stare, the more it unsettles you, not because it is reversed, but because it doesn't feel reversed, and yet it is, and not in the way you expect. Mirror reversal confusion begins not with the image, but with your mind's attempt to reconcile it with lived experience. Because in the physical world, left and right are relational, context, bound, direction, dependent. But in the mirrored world, something odd happens. Your front remains your front, your top stays your top. But left and right seem to trade places, even though the mirror doesn't actually flip you horizontally. It's you who flips, mentally, spatially, neurologically, because the mirror performs a transformation not of physics, but of perspective. It reflects along the z-axis, not the x or y-axis, meaning it doesn't truly reverse left and right. It reverses depth. If you hold up a sign that says, love, the mirror shows it backwards, not because it reversed left and right, but because it reflected light straight back, making it appear as though the sign turned around. And yet, in your brain, the reversal feels lateral, not frontal, because you interpret mirrored images as if someone else were standing across from you. So you apply a mental rotation, unconsciously imagining yourself flipped around to face you, and in doing so, you invert the wrong axis. This act of mirroring your own body is a powerful illusion born from embodiment, from the way your sense of self is anchored in space. You aren't just looking at your face, you're reconstructing where your limbs would be if the person in the mirror were a real human facing you. It's a kind of spatial empathy you don't even notice you're doing. And this becomes even more confusing when we look at how the brain builds spatial orientation. Your body has a mental map of itself, a somatosensory representation constructed from tactile feedback, proprioception, and visual cues. When you move, your brain predicts what that movement should look like from your own viewpoint. But mirrors disrupt that prediction by offering a third-person reconstruction of a first-person act. It's like seeing yourself from outside your own body, yet reacting as if you're still inside it. This dissonance creates what's known in psychology as mirror agnosia, or left-right confusion, in more extreme neurological cases, particularly in individuals who suffer parietal lobe damage. But even in healthy brains, the mirror world unsettles the spatial narrative you've spent a lifetime building. Consider this. If you write your name on a piece of transparent glass and flip it horizontally, you'll see the same reversed image as in a mirror. But if you rotate that glass 180 degrees vertically instead, you'll also see a reversed version. But now the top and bottom are reversed, not the sides. Why does the brain process the first as more intuitive than the second? Because our lives are lived in bilateral symmetry. Most of your environment and actions occur along a horizontal plane. You shake hands left to right. You look left and right before crossing a street. You read text from left to right, or right to left depending on your language. Vertical reversals feel alien, unnatural, because your world doesn't demand them as often. So the mirror tricks you not by altering the image, but by exploiting a bias in how you expect symmetry to behave. And then there's the strange emotional layer, the moment you look into a mirror and feel like you're not seeing yourself, but a stranger who's been assigned your face. This is called the mirror self-misidentification delusion, and while rare in the clinical sense, its subtler version touches almost everyone at least once. especially in times of emotional stress or identity crisis. There's a haunting moment when you glance into a mirror and feel unrecognizable. Not because your features have changed, but because something inside you has shifted, and now the reflection no longer aligns with who you think you are. This dissonance speaks to how fragile identity is. How much of you depends not on facts, but on congruence between internal expectation and external perception. The mirror doesn't just reverse your body, it reveals its boundaries. You see the limits of your skin, the mask of your expression, the outline of your form. And yet, you sense that so much of who you are exists just behind the glass, unreachable and unseen. You realize the reflection is just light bouncing back from a surface, and still, you search it for truth. You study your own eyes as if they hold the answer to something your mind won't tell you. This is the human paradox, to know that the image is an illusion, but to still look to it for self-validation. You smile in the mirror to test your own happiness. You frown to feel your sadness confirmed. And when you turn away, it's as if you left someone behind, someone who moves like you, breathes like you, but might say something different if they ever spoke. The confusion deepens when you realize that your brain's ability to recognize faces, including your own, is not merely visual, but a synthesis of dozens of features processed in parallel. The fusiform face area, a region in the temporal lobe, handles the intricate task of facial recognition, but it doesn't operate alone. It collaborates with memory centers, emotional valence systems, and proprioceptive feedback. This is why photographs of yourself often feel off, because they lack the mirror reversal your brain has come to expect when viewing your own face. You've grown used to seeing yourself flipped, and so the photo looks wrong, not because it is inaccurate, but because it is unfamiliar. The same goes for video recordings. You gesture, speak, and move in ways that feel alien, even though others see them as normal. You begin to understand that your self-image isn't just a picture. It's a lived perspective, built moment by the way you experience yourself moving through space. Mirrors violate that continuity. They offer a permanent echo of your body, frozen in the wrong symmetry. And yet you adapt. You shave, do your makeup, check your clothes, trusting that the reversal will translate back into the real world correctly. And somehow, it does. You develop mirror habits, tilting your head a certain way, adjusting posture, modifying expressions, not to look better, but to look familiar. You learn to become fluent in a language spoken only in glass. And still, the confusion persists when mirrors break their passive role, like in mirrored rooms, infinity chambers, or mirrored sunglasses that bounce your own face back at you when talking to someone else. The layers of reversal become recursive, and your brain struggles to anchor its sense of presence. You feel duplicated, scattered, dislocated. The philosopher Jacques Lacan famously referred to the mirror stage, in child development, as the moment when a child first recognizes themselves in a mirror, and from that recognition begins to form a coherent ego. But what he also hinted at is the fracture, the realization that the image is both self and not self, both you and other. You live with this fracture every day. You accept the mirrored self as you, even though it's technically never something anyone else sees. No one in your life has ever experienced the version of your face you see in the mirror. It's a private version of yourself, a personal illusion, a one-sided secret. And perhaps that's why it feels so intimate. The mirror becomes a portal, not to truth, but to a version of you built just for you. An echo chamber for identity. And when the confusion strikes, when the reversal feels too strange, when the smile doesn't look right, when your body moves in unexpected ways, you're reminded that even the most familiar image in your life is in the end only a reflection. And so you return to that quiet moment, standing in front of the mirror, raising your hand again, watching the opposite lift in response. It's a small gesture, but it carries centuries of philosophical weight. You're not just testing symmetry, you're confronting the boundary between representation and reality. You're asking yourself, silently, if the person you see is really you, or just the version that light and expectation allow you to believe in. You begin to understand that the confusion isn't a flaw, it's a feature. A mirror is a tool not for clarity, but for confrontation. It shows you what others never see. It lets you rehearse the self you hope to be, and it reminds you, in its reversed logic, that identity isn't fixed. It's mirrored, refracted, and forever in conversation with the self you're becoming. Color constancy. You open your eyes in a room flooded with light, and without needing to think, you know the banana on the table is yellow, the apple red, the paper white, and your hand exactly the shade it always is. Even though the morning sun is slanting in at an angle that should distort everything, casting gold across the floor, washing the walls with amber. And yet, the colors hold steady, faithful to their identity, immune to the changing light. And what's quietly astonishing is that you never notice the miracle of this stability, because it's always there, quietly correcting, seamlessly adapting, keeping the world constant while the environment shifts around it like the weather over a landscape. This phenomenon, color constancy, is one of the brain's most elegant illusions, a perceptual correction so automatic, so reliable, so foundational to your experience, that you never think to question it. But if you were to pause, to truly observe how effortlessly your mind edits the world to keep it familiar, you begin to see how much of what you believe you see is not what's there, but what your brain insists must be there. A best guess dressed as certainty. Scientifically, color constancy is the ability of the human visual system to perceive the color of an object as relatively constant under varying illumination conditions. That means when the lighting changes from sunlight to candlelight, from cool fluorescence to warm tungsten bulbs, your brain recalibrates what it thinks the object's true color is, filtering out the influence of the surrounding light. But this isn't a straightforward optical process. It's a high-level cognitive correction, a visual negotiation between your eyes and your expectations. A computational trick in which the brain factors in context, shading, contrast, and surrounding hues to stabilize what should otherwise be a chaotic mess of ever-shifting wavelengths. Light hits an object, reflects back to your retina, and the cones in your eyes register a spectrum of frequencies. But your brain doesn't just take those signals at face value. It compares them to surrounding surfaces, infers the light source, adjusts for shadow, and makes a decision. This shirt is blue, even though it reflects different wavelengths in the morning than it does at night. And you, unaware, trust that judgment. But sometimes, when the context becomes ambiguous, when the lighting is just uncertain enough, when the surrounding cues are minimal or misleading, your brain's assumptions can be exposed, and reality begins to slip. You might remember the viral internet debate over the color of a dress, white and gold or blue and black, and how half the world saw one thing, the other half something else. Each side convinced of their truth, each perception backed by genuine belief. That dress wasn't just a meme, it was a portal into the machinery of perception, a rare moment when color constancy faltered just enough to reveal its presence. Because the dress image lacked clear lighting cues, your brain had to guess whether it was lit by shadow or by direct light. And that single guess flipped the colors entirely. And in that moment, the truth became unstable. Identity became opinion, and millions of people experienced firsthand that seeing is not the same as knowing. Color constancy is a form of perceptual constancy, one of many tricks the mind uses to keep your experience of the world coherent, even when the raw data disagrees. It's why grass still looks green at dusk, why snow seems white under a yellow streetlight, why your face looks familiar even in the tinted mirror of a car. Without this constancy, colors would shift dramatically every time you walked from one room to another. Every time a cloud passed overhead, every time a candle flickered beside you, the world would be unstable, slippery, untrustworthy. You'd be unable to rely on visual identity, unable to learn from repetition, unable to name a thing and mean it in every light. And yet, what's most fascinating isn't the correction itself. It's the implication beneath it that the world you see isn't made of raw colors at all, but of stories your brain tells about color. That you don't see color directly. You see color through expectation, context, and experience. You see color through memory, and memory, as you know, is not infallible. It's curated, sculpted, filtered like sunlight through a stained glass window. You remember a red door from childhood, but was it truly red? Or did your mind decide it must have been red because red felt warm, welcoming, bold? You recall your grandmother's kitchen as yellow, but was it always yellow, or did you color it that way in retrospect, painting nostalgia across your recollections like an emotional filter? Your perception of color is deeply tied to language, culture, and emotion. Some cultures have more words for certain hues than others, and those linguistic distinctions shape what their speakers actually see. There are tribes with no word for blue, and studies suggest they genuinely struggle to distinguish it from green. Conversely, there are cultures with multiple distinct words for what you call white, and they see subtle differences you've trained yourself to ignore. So color constancy isn't just about light correction, it's about cognitive calibration, a learned agreement between your biology and your beliefs, between your senses and your symbols. It's the brain's way of saying, I know what I've seen before, and I trust that it hasn't changed just because the sun moved. But this trust can be dangerous too. It can make you overconfident in your perceptions. It can convince you that what you see is objective when it is, in fact, filtered through layers of unconscious processing. It can blind you to changes, to nuances, to ambiguity. You might not notice that a friend's mood has shifted, that a room has grown colder in tone, that a memory has begun to fade, because your brain insists on constancy even when reality is drifting. And so, color constancy becomes a metaphor for emotional constancy, the way we project stability onto people and places, even when they've changed. You might still see someone as kind, even after they've hurt you, because your brain, trained on years of affection, filters out the new shadows. You might still see home as safe, even when it's grown unfamiliar, because you've painted it with the same hues for so long. Your mind refuses to recolor the walls. You might look at your own face in the mirror and see the version you remember, not the one time has created. In this way, color constancy is a form of emotional inertia, a resistance to update the palette of our lives. It's comforting, yes, but it can also trap us in outdated versions of reality. The world may be changing around you, and you might not notice, not because you're careless, but because your mind is too careful, too committed to its own corrections. And so, as you move through your day, take a moment to notice the color of things, not just their labels, but their lived light. See how the sky shifts at dusk, how a shirt looks different in your bedroom than in a department store, how someone's eyes change when they laugh. Let yourself question what you see, not to doubt your senses, but to marvel at their complexity. Realize that perception is not passive. It's creative, interpretive, alive. Your brain is not a camera. It is an artist, and like any artist, it chooses what to reveal, what to emphasize, what to omit. You don't just see the world, you co-author it. You correct its light, adjust its tones, stabilize its shapes, and in doing so, you maintain the illusion that the world is consistent. But beneath that illusion, there's motion, there's drift, there's a subtle flicker of truth waiting to be seen. So open your eyes again, and this time really look. Not just at color, but at the process behind color, at the decisions your mind makes in silence, at the beauty of a world you think is constant, but that's actually dancing, always in light that never stays still. Size, weight illusion. You pick up two boxes, one small and one large, and though they weigh the same, something strange happens. The smaller one feels heavier in your hand, denser, more resistant to motion, as if gravity had pulled more tightly on it for some secret reason only your body can sense. And in that simple act, in that private moment of surprise, you step quietly into one of the brain's most persistent perceptual illusions, the size-weight illusion. a psychological riddle where expectation, experience, and physics collide inside you without your awareness, crafting a version of the world that feels intuitively true but isn't, not really. And the longer you hold the objects, the more certain you feel. Not because the illusion is fading, but because your mind is adapting its grip, adjusting its internal model, negotiating the strange mismatch between what your eyes see and what your muscles report, and you trust your body. Of course you do, because your entire life you've carried things, lifted them, judged them, gauged their heft by their shape, and in that vast library of remembered effort, your brain has stitched together a rule: bigger things should weigh more, and when they don't. When something defies that silent expectation, your nervous system doesn't revise the rule, it bends the sensation. It tweaks perception to preserve the story it already believes. And in doing so, it reveals not just a quirk of touch, but a deeper truth about how you perceive reality. Not directly, not purely, but through layers of inference and assumption, through predictions woven into feeling, through a body that doesn't just react to the world, but interprets it, prejudges it, fills in blanks to stay coherent in a chaos of sensation. And what's fascinating is that the size-weight illusion is nearly universal, robust across age, culture, and context, and resists even after you've been told the truth, after you've weighed the objects, seen the numbers, felt the balance. And still your hands insist. The smaller one is heavier, which tells you something critical about the nature of perception. It is not corrected by knowledge alone. It is not a slave to fact but a dance of embodied belief. A story your body tells before your brain catches up. And this illusion isn't just a curiosity of psychophysics. It's a window into predictive processing, into the way your brain uses past experience to guess what the world should be like before it even touches it, and then retrofits your sensations to align with that prediction. Not because it wants to deceive you, but because perception is not about truth. It's about usefulness, speed, coherence, and survival. And if you had to compute every input from scratch, you'd be paralyzed by data, drowning in weightless details. But your brain shortcuts the chaos, says, "I've seen this before," and lets you move through the world without hesitation. And yet, in doing so, it makes mistakes. Illusions like this one, where size whispers one thing and weight says another. And instead of choosing sides, your mind blends them, creating a false but stable perception that feels solid, unshakable, until you look closer. And what's even more extraordinary is that this illusion doesn't vanish with repetition. It adapts but persists, like a memory your body refuses to overwrite. And in controlled studies, when subjects are given two identically weighted boxes of different sizes and asked to lift them repeatedly, their muscle output gradually adjusts. They begin lifting both with equal force, but their perception of weight never aligns. They still feel the smaller one is heavier, which shows you that action and perception can diverge, that your motor system can learn a truth, your perceptual system resists, and that duality is hauntingly familiar, isn't it? How often do you know one thing logically, but feel another emotionally? How often do your actions move with awareness, while your perceptions cling to old scripts? How often do you find yourself carrying an idea that should be lighter than it feels, or struggling with a memory that should weigh nothing now, and yet lingers like a stone in the chest? This illusion echoes those inner contradictions, a physical metaphor for cognitive dissonance, a tactile reminder that your mind and body are not always in agreement, and that your perceptions are not mirrors but mosaics. Assembled, guessed, filled in by instinct and past experience. And you begin to realize that every time you lift something, you're not just feeling its mass. You're measuring it against the unseen ledger of your life, against every time you've lifted something similar, against a background hum of sensory memory that sings before you think. And you trust that music even when it's wrong, because it feels familiar, because it helps you move. But let's go deeper. Why does your brain build this illusion in the first place? Why not recalibrate once it notices the mismatch? Because recalibration takes time, and perception is always playing catch. Up and in the race between prediction and sensation, the brain privileges the prediction. It would rather be consistent than correct. And this is what keeps you stable in a shifting world. What allows you to pick up a coffee mug in the dark, to judge the heft of a suitcase without opening it, to catch a ball in midair, based not on where it is, but where it will be. Your brain is always anticipating, always running ahead of the moment, and the size-weight illusion is the cost of that efficiency. A perceptual tax you pay for a life that flows. And you begin to realize how much of your reality is constructed like this, built not from what is, but from what you expect, what you've learned, what your body believes even before you do. And in that awareness, you start to see the world not as a set of fixed truths, but as a choreography of guesses, constantly refined, rarely perfect, always in motion, that your body is trying to help you, trying to make the world make sense, even if it has to lie a little, even if it has to bend sensation to fit the story. And that same mechanism helps you walk without falling, love without certainty, remember without recording, that you are, in essence, a being of illusions, stitched together by useful fictions that keep you moving forward. And maybe the goal is not to discard those illusions, but to understand them, to hold them gently, to realize that feeling heavier doesn't always mean being heavier, that sometimes your sense of weight is emotional, historical, imagined. So the next time you lift something and feel its weight in your hand, pause, not to doubt, but to listen, to the whisper of your brain's story, to the invisible expectations wrapped around every object, to the way size and shape and past experience conspire to create your present, and then carry that awareness into your day, into the way you judge effort, evaluate people, assign meaning to things that feel too heavy or too light emotionally. Because the size-weight illusion doesn't end at the wrist. It stretches into the heart, into the way we misjudge burdens, overestimate what others carry, underestimate our own resilience, assume that small things can't matter much, or that big things must be hard to hold. When in truth, it's the invisible forces, the assumptions, the memories, the context, that give weight to what we feel. And once you understand that, once you see that every object is not just a thing, but a thought shaped by expectation, you begin to move differently, less certain, perhaps, but more aware. And maybe that's the beginning of wisdom, not to see clearly, but to know when you're being tricked gently by your own mind, and to smile anyway, and to carry on. Temperature confusion illusions. You reach for a metal doorknob and instinctively recoil. It feels cold, sharper than expected, as though it's somehow colder than the air around it, colder than your own skin, and colder than it should be. But is it really colder? Or are you simply being tricked by a nervous system evolved for survival, not for precision? Temperature, despite its scientific definition as the average kinetic energy of molecules, is not a number your body reads directly. It's an experience your brain constructs from context, contrast, and expectation. And nowhere is this clearer than in the illusions it creates. Sensations of hot that are not hot. Sensations of cold that are not cold. A world where touching two metal rods of the same temperature can feel entirely different depending on your past exposure or what your eyes see. The thermal grill illusion, for example, places alternating warm and cool bars against your skin. And what do you feel? Not warmth, not coolness, but a bizarre burning heat. An illusory pain that doesn't exist in either stimulus alone, but emerges from the pattern, a synthetic perception created by the collision of sensory pathways, where your warm and cold receptors fire simultaneously, and your brain misinterprets the overlap as danger, as injury, as fire, though no actual heat is there. And then there's the paradox of adaptation. A lukewarm bucket of water feels hot if you've just had your hand in cold water, and cold if you've had it in hot. Not because the water changes, but because your skin has recalibrated its expectations, and you are now feeling not the water, but the contrast, the delta, the change. You live in a body that compares everything: light, weight, texture, sound, but perhaps temperature is the most context dependent of all, because it's not only comparative, it's reactive. Your nerves don't passively receive heat, they actively respond to it, firing with greater or lesser urgency, depending not only on the physical stimulus, but also on its novelty, your mood, your stress level, even your sense of control. A room can feel cold if you are anxious, and warm if you are at peace. A breeze can soothe you or bite you depending on how welcome it feels. There is no such thing as raw temperature in your perception. There is only interpreted sensation, a narrative your body constructs moment by moment, and sometimes these narratives lead to hallucinations. Phantom heat, imagined cold, thermal synesthesia, where some people see temperature in color or shape, or feel it emotionally as anger, comfort, nostalgia. In certain neurological conditions, like multiple sclerosis, temperature can seem to fluctuate wildly when it doesn't. In phantom limb patients, heat can be felt in a hand that no longer exists. And in some rare cases, a lesion in the brain can reverse heat and cold entirely, making ice feel scalding and warmth feel like frost. What does this tell you? That your thermal sense is not a thermometer. It's a storyteller. It guesses. It infers. It sometimes panics. And it always blends what is out there with what is already in here. This is why a hot compress on your skin can relax your mind, and why heat therapy can reduce not just pain, but sadness, because warmth is more than physical. It's symbolic, emotional, even existential. The infant cries not only from cold, but from absence, and it quiets not only from heat, but from presence. Warmth is safety, cold is aloneness, and your brain, built on millennia of evolutionary learning, encodes this wisdom deep into your wiring. So when illusions happen, when the warmth you feel isn't real, or when you sense heat in something cold, it's not a failure of biology, it's the echo of all the stories your body has ever told itself about danger, about safety, about connection and threat. And the more you learn about it, the stranger it gets. Did you know that thermal illusion can affect pain thresholds? That holding something warm can make you feel socially closer to others? That rejection can burn and loneliness can chill? These are not metaphors. They are measurable, neurological phenomena where social and physical thermoregulation overlap, and your brain, unable to separate the two, uses the same circuits for both. Which means that, yes, emotional warmth and physical warmth are siblings, sharing space in your body's architecture, meaning you quite literally warm up when you feel loved, and cool down when you feel forgotten. These illusions of temperature are not minor glitches. They are deep insights into the way you construct reality itself, because every sensation you trust is filtered, adjusted, and framed by a nervous system that is trying to predict what matters most. It's a dance of expectation and reaction, a loop of feedback that never quite matches the outside world, and yet is good enough to keep you alive, even if not always accurate. And in this dance, you learn to trust feelings that are sometimes true and sometimes echoes. Because what you feel isn't just heat or cold, it's memory and context, fear and familiarity. Your body, in a sense, is a translator between the physics of the world and the poetry of your perception. And sometimes, it gets the translation wrong. But maybe that's okay. Maybe in those mistakes, those thermal illusions, those phantom burns and imagined chills, you can glimpse how fluid your reality really is, and how incredible it is that even in confusion, you still find meaning, you still respond, you still reach toward warmth, and that reaching, that longing, that illusion, might just be the most human feeling of all. Afterimages. You stare at the candle, its flame steady, its light warm, its edges dancing in place, like a small whisper of time, and when you finally look away, just a blink, just a pause. It follows you, doesn't it? Not the candle, but its echo. A glowing silhouette hovering in your vision like a phantom, pale green or deep magenta, or some flickering afterthought of light, refusing to fade, imprinting itself onto the blank space of wherever your eyes now rest. This is an afterimage, a visual memory that wasn't consciously written, but nonetheless insists on being read, lingering not because of nostalgia, but because your nervous system isn't quite ready to let go. Your retina, made of rods and cones tuned to light's subtle waves, doesn't shut off instantly when the stimulus disappears. It continues firing, just for a moment, as if your mind needs a few more seconds to believe that what you saw is now gone. But the phenomenon is more than leftover light. It is the physiology of persistence, the biology of delay, and the psychology of interpretation. The most common afterimage is negative, when you stare at a red square and then shift your gaze to a white wall. You see its ghost in green, its complementary opposite. This happens because the cones in your eyes responsible for color perception become fatigued. The red sensitive cones, overstimulated, quiet down, and when you look away, the green cones, which were less active, dominate momentarily, giving rise to the illusion of color that isn't actually present. But even knowing the mechanism doesn't diminish the eeriness. There's something strangely haunting about it, that your own senses replay moments without your consent, that the world you see now contains shadows from a moment ago, like visual memories stuck in time. And sometimes these echoes grow more complex. Stare at a checkerboard, and you may see grid, like illusions overlay your world. Focus on a spinning wheel, and when it stops, the room may seem to twist in the opposite direction. Afterimages don't just reflect color. They reflect motion, texture, even implied light. And the deeper question is this: why does your brain allow these illusions at all? One theory suggests its efficiency. Your neurons predict patterns and extend them briefly to avoid constant recalibration. In other words, the system favors continuity over accuracy, echoing the past into the present to smooth out perception. But another possibility is more poetic, that your brain, in trying to make sense of the world, is not just detecting reality, but reconstructing it. And sometimes it reconstructs a little too long. Afterimages are evidence that perception is not an immediate translation, but a layered process with echoes, decay, and momentum. Think about it. Even your experience of the now is slightly delayed. Your visual processing takes roughly 80 milliseconds. So what you're seeing is not what is, but what was, slightly adjusted and edited for clarity. Afterimages, then, are like the brushstrokes left over when the painter has moved on to the next canvas. But they're not just visual curiosities. They occur in almost every sensory modality: auditory afterimages, where a loud sound seems to ring in silence; tactile ones, where a gentle pressure seems to remain after a touch; emotional ones, where a strong feeling colors everything that follows. Your entire reality is layered with perceptual residues, and perhaps the strangest thing is that some afterimages are entirely mental, formed not by light or sensation, but by thought. You can imagine a bright object, focus on its imagined shape, and when you stop, you may still see it faintly. These are ideoretinal afterimages emerging from visualization alone. So now you're not just seeing what you saw, but what you imagined you saw. The distinction begins to dissolve. Afterimages blur the line between perception and memory, between the immediate and the remembered, between real and residue. And the more you observe them, the more you notice how often your reality is not about the present, but about what just left. Consider how this maps onto your emotional world. How often do you see someone through the lens of a past conversation, a memory, a hurt? How often does your current mood reflect something that happened hours ago, like the retinal afterimage? Your emotional afterimages color interactions long after the trigger fades. Someone smiles, and you brace for sarcasm, because an old wound still burns faintly. Someone says your name, and you hear it in the voice of someone long gone. And just like the ghost of the candle's flame, these after feelings hover on your mental walls, faint and flickering, not real anymore, but not yet forgotten. Your mind, like your eye, does not erase easily. It echoes. It lingers, it persists, and it must, because identity, like vision, depends on continuity. To be you is to remember what just happened, even as it fades. Without this persistence, you'd forget who you are between every blink. But afterimages also teach restraint. They teach you that what you perceive might not be current, might not be accurate, might not be relevant anymore. They whisper, "This is a shadow, not a truth." And with that realization comes power, the power to question, to reframe, to wait before reacting, to say, maybe what I'm feeling isn't about this moment, but about the one before. Maybe I'm seeing what was, not what is. And if you can hold that awareness even briefly, you can live with more clarity, more softness, more space. Because just as light leaves trails across your vision, experience leaves trails across your life. Some are beautiful. The afterglow of love, the warmth of a memory. Others sting, the ghost of regret, the ache of something lost. But they are all part of the same system, a mind that carries more than the present, a self that holds echoes, and a body that even when the light goes out, remembers how it felt to see. So next time you catch a glimmer of something that's no longer there, whether on a wall, in a face, or in your heart, don't rush to wipe it away. Sit with it, let it fade naturally. And in that fading, feel the wonder of being a creature who not only perceives, but remembers light. Motion blur, false memory. You may not remember it clearly, but the moment you turned your head to catch a glimpse of something speeding past, a cyclist, a falling leaf, the blink of someone's gesture, your brain made a decision it never told you about. It decided to blur the lines between time and space just long enough for you to believe that you saw what you didn't, or didn't see what you thought you did. This quiet illusion, often hiding behind the everyday choreography of attention and perception, is known as motion blur, induced false memory, one of the many hidden negotiations between your mind's need for continuity and its inability to perfectly freeze time. At first glance, it seems like nothing more than a hiccup in the visual system, an artifact of speed, like streaks of rain across a moving window. But look deeper, and you'll find something far more profound. Your brain, caught between truth and assumption, crafting memories, not from reality, but from the ghost of motion. When objects move rapidly in your field of view, especially while your gaze or attention shifts, your visual cortex fills in the blanks between frames with assumptions, guesses shaped by experience, context, and cognitive shortcuts. This mechanism evolved not to deceive you, but to help you survive. In nature, the ability to detect movement, even imprecisely, was more useful than capturing every frame with photographic precision. Yet, in the modern world, where cars streak past and screens flash by, these ancient instincts can misfire. You might misremember the path of a falling cup, the color of a jacket in a sprinting crowd, the sequence of a gesture, all because your mind, rather than accept uncertainty, stitched together a plausible story, painting over gaps in time with a motion blur, so convincing you swear it happened that way. This illusion becomes especially powerful when what you see contradicts what you believe you saw, and your memory quietly chooses narrative over accuracy. It is why eyewitness testimony can falter under pressure, why a crime victim might be certain about the details of a fleeting moment, only to discover they had subconsciously invented continuity where none existed. Your perception of motion isn't continuous. It is predictive. The brain anticipates future positions based on past data, creating a seamless sense of flow. But when it guesses wrong, the result isn't just a mistaken impression. It can rewrite memory itself. These errors don't feel like lies. They feel like truth wrapped in motion. And here's the quiet trick. Your mind doesn't alert you when it is guessing. It feels the same as when it is certain. So you walk through your day carrying memories of moments, faces, events, that may be painted with strokes of speed, induced fiction. In lab settings, psychologists have replicated this by showing subjects brief images of objects in motion. Participants often recall seeing positions that were never shown, remembering intermediate frames that didn't exist. This phantom perception, called representational momentum, shows how strongly the brain favors motion continuity over still frame fidelity. It wants things to make sense, to move logically, to not vanish without explanation. But motion blur isn't limited to vision. It blends with attention, emotion, even sound. When you hear someone shout from a passing car, your brain may stretch the voice across the fading Doppler trail. When a dog darts across the room, you might remember the ball being thrown just before it happened, because your brain retroactively fills in cause and effect to make the blur coherent. And in this dance between senses and speed, you begin to realize that memory isn't a recording, it's a reconstruction. Every time you recall a fast moment, you reassemble it from fragments, visual traces, emotional echoes, contextual predictions. Each replay is a recreation, not a replay. And in those high-speed recreations, blur becomes meaning. The faster something happens, the more your brain smooths it out, and the more likely it is to misremember it. This is not a flaw. It is a feature, a beautiful one. Your mind is not trying to deceive you. It is trying to make life livable. Imagine what it would be like to remember every detail of every second with photographic precision. You'd drown in raw data. Instead, the mind edits for meaning, cuts for story, applies motion blur to transitions, so that life feels more like a film than a slideshow. But just like in a film, if you freeze the frame, you see the trick. You notice the smudged edge, the implied trajectory, the illusion of motion that never truly existed, and so you learn, slowly, to question what you remember. Not because your memory is broken, but because it is human. Philosophically, motion blur false memory raises haunting questions. How many of your vivid, decisive memories are built on velocity rather than substance? How often do you reconstruct the past, not from fact, but from your brain's insistence that time and space must flow smoothly, even when they don't? Perhaps your memory is not a library of what happened, but a gallery of what felt like it happened. And speed, the blur of action, becomes the brush your brain uses to fill in the fog. And what does this mean for truth, for testimony, for love, or regret, or nostalgia? If your most vivid recollections of someone, how they moved, how they smiled, how they left, are shaped by blur, do you love the person or the motion of them? Do you mourn the reality or the momentum? Maybe that's what makes fast moments feel so emotionally charged. They blur into myth as soon as they pass. And when you miss someone, it's often not the details you miss, but the motion. The way they turned toward you, the way their voice rose and fell, the way time itself seemed to skip or stretch when they were near. The illusion of motion becomes the emotion of memory, and just like that, science bends into poetry. So the next time you turn your head and something blurs past, remember that you won't remember it exactly. And maybe that's okay. Maybe life isn't meant to be captured frame by frame. Maybe it's meant to be felt in motion, even if the blur sometimes rewrites the story. After all, the motion may have been false, but the memory, the feeling is yours, and sometimes that's real enough. Müller-Lyer Illusion. You look at two simple lines, clean, black, and straight, identical in length, side by side on a page, each with little arrowheads at their ends, one pointing inward like the corners of a room, the other flaring outward like the edges of a roof, and something in you immediately says, without thinking, without doubt, that one line is longer than the other. And even when logic taps you on the shoulder and shows you the ruler, you can't shake the instinct that one extends further, reaches more, stretches across more space. And this quiet dissonance, this tug of war between what you know and what you see, is the essence of the Müller-Lyer illusion, a deceptively simple, yet profoundly revealing phenomenon that has puzzled scientists, artists, philosophers, and perceptual psychologists for over a century, exposing not just how vision works, but how your entire mind builds reality from fragments of visual hints, spatial metaphors, and deeply embedded assumptions about the physical world. The illusion was first described in 1889 by German sociologist Franz Karl M. Müller-Lyer, and at first glance, it seems laughably basic, just a pair of lines with arrow tips. But the longer you look, the more it becomes clear that this is not merely a visual trick, but a revelation. Your brain does not report the world, it interprets it. You don't see with your eyes, you see with your mind. And that mind is constantly making corrections, assumptions, predictions about what depth, distance, and scale should be, based on an internal model built from years of walking through rooms, seeing corners, gauging depth from walls, interpreting how things extend toward or away from you. In the Müller-Lyer illusion, those arrow tips act like visual cues from the real world. When the arrows point inward, they resemble corners receding into space. When they flare outward, they resemble edges projecting toward you. And without conscious thought, your brain translates those simple shapes into a depth map, falsely perceiving one line as farther away, and compensating for that by mentally stretching its length to match what it should be if it truly were farther. And so, ironically, the lines that are identical become unequal, not because your eyes are broken, but because they're too well trained to attune to the geometry of space and the rules of three-dimensional living, which they mistakenly apply to a two-dimensional image. This illusion is not universal, or rather, its strength and effect vary across cultures, across geographies, across ways of living. And this is one of the most haunting insights it offers, that perception is not only biological, but cultural. In societies where people are raised in carpentered environments, cities, rooms, angular buildings with sharp edges, and rectangular layouts, the illusion is powerful and immediate, because their visual systems have been conditioned to associate arrow-like angles with spatial depth. But in cultures where architecture is rounded, where nature dominates the visual field, where visual cues are curved rather than right-angled, such as in some indigenous tribes or nomadic groups, the illusion loses its grip. They see the two lines for what they are: equal. This simple test, two arrows and two lines, becomes a measure not just of sight, but of experience. It suggests that your perception of space is not fixed, not absolute, but molded by the environment you grow up in, shaped by the daily contours of your visual world, subtly programmed by the architecture around you. And this realization opens a deeper philosophical doorway. If your mind can be trained by walls and windows to see distance where there is none, how many other illusions are you walking through each day, unknowing? How many mental Müller-Lyers are built into the very structure of your beliefs, your values, your sense of self and others? Neurologically, the illusion is tied to what scientists call size constancy and depth cue integration, two processes by which your brain attempts to maintain a stable understanding of the world, despite changing visual input. When you look at a hallway that narrows toward the end, you don't think the floor is shrinking. You interpret that shrinking as depth. When someone walks away, you don't believe they're becoming smaller. Your brain adjusts for distance. The Müller-Lyer illusion hijacks these mechanisms. It feeds your brain two shapes that mimic familiar depth cues, and your brain, trying to make sense of flatness, injects depth where there is none. This speaks to a profound cognitive truth. You are wired to see more than what's there, to fill gaps, resolve contradictions, and make space feel coherent even when it isn't. And while this is helpful for survival, for catching thrown objects, walking down stairs, or recognizing faces at a distance, it also opens you up to misperception, to illusions that, like the Müller-Lyer, trick not your eyes, but your interpretation of your own sensory data. And here's the unsettling part. Even once you understand the illusion, even when you've studied the diagrams, read the papers, Watch the ruler slide back and forth to prove equality. The illusion does not vanish, that irrational certainty lingers. That gut-level perception refuses to yield, because understanding is not the same as rewiring, because your brain, even when corrected, clings to its version of reality in modern applications. The Müller-Lyer Illusion isn't just a curiosity. It becomes a testbed for exploring how the brain processes geometry, spatial logic, and visual learning. It's been used in virtual reality research, where depth cues can be precisely controlled and manipulated, revealing how fragile spatial awareness becomes when the body is removed from physical anchoring. It's studied in relation to artificial intelligence, as scientists try to teach machines how to see and interpret space, and in doing so, uncover just how complex and ambiguous human vision really is. But perhaps most poignantly, it has been used in therapy and neurology to understand patients with damage to the parietal lobe, or those with visual agnosia, who cannot reconcile what their eyes see with what their brain understands. For them, the Müller-Lyer illusion is not an amusing quirk. It's a window into how fractured perception can become when the mind's geometry engine malfunctions. They may see lines, but not distance, shapes, but not depth, and in that gap lies a quiet kind of suffering, the dissonance between reality and perception, between seeing and understanding. But even for you, with an intact visual system, the illusion remains a mirror, not to your eyes, but to your assumptions. It invites you to consider how often you mistake inference for fact, how often your mind completes stories, guesses intentions, fills in gaps in conversations, in relationships, in memory. You remember a tone that wasn't there. You assume a distance someone didn't mean. You read into silence, a message never sent, just like the line with arrowheads. These are illusions you carry, not because you're flawed, but because your brain is designed to interpret, to guess, to resolve. The Müller-Lyer illusion becomes a metaphor not just for visual misperception, but for emotional and social misreading. You stretch meanings, you elongate wounds, you compress kindness, you shape the flatness of experience into three-dimensional narratives that feel true, even when they aren't, and maybe there's something beautifully human in that. The way you reach beyond the literal, the way your mind refuses to be passive, the way it insists on building space, building depth, building meaning from the simplest strokes of life, a line, a gesture, an absence, all becoming longer or shorter depending on the angle from which you view them. The Müller-Lyer illusion doesn't just live in optical psychology journals. It lives in every moment you interpret someone else's behavior, every time you take flat information and assign it shape, motive, history, and perhaps, just perhaps, the best you can do is remember that your perception, no matter how confident, is always a guess, that what feels longer may not be, that what feels deeper might be flat, that what seems obvious might be shaped not by truth, but by expectation. And in that pause, in that fragile space between what you see and what you know, lives the chance to reflect, to question, and to gently revise the illusion.